My name is Nelson, and in this course you will learn about a database called Postgres. Postgres is by far one of the most popular databases out there, and the cool thing about it is that it's open source, robust, high performance, and it comes with a lot of great features. And for that reason, a lot of startups are using it for their backend applications. And you, as a software developer or engineer, you should be aware of this database, how to use it for your own projects, as well as for your own career as a developer. We're going to start this course by understanding exactly what a database is, the story behind Postgres, and then I'm going to show you exactly how to set it up on both Windows and Mac OS users. Now, I want to be really straightforward with you in this course, and that is we're not going to learn how to use Postgres or this database called Postgres by using some graphical user interface, because I don't think that that's fair when you learn a database by pretty much just clicking and dragging and adding things by using some UI, because that way you're not really understanding how the actual logic behind works, right? So in this course, we're going to be using a interactive shell called PSQL, and pretty much we're going to be using the terminal or command line. And just to let you know that it's not difficult, I'm going to make sure that it's very straightforward, and by the end of this course, you'll be very familiar by using terminal or command line to work with databases. And to be honest, if you were to SSH into a remote server, you wouldn't have the ability to use one of those graphical user interface clients because, to be honest, like no one does it, right? And also sometimes it can be very slow, so on and so forth. But towards the end of this course, obviously I'm going to show you, available options for both Windows and Mac users. But the best way of learning any database is by getting your hands dirty, by pretty much learning the raw commands behind everything you do. So once we set up everything, we're going to go ahead and dive into the fundamentals and essentials of Postgres. So Postgres uses SQL as its main query language, and we're going to go ahead and learn how to create databases, how to create tables, how to insert records into the database, how to delete, update, and also understand how we can actually join two tables together, foreign key relationships, sequences, how to export to CSV, grouping, aggregation, database constraints to make sure that we don't have garbage data in our tables, primary keys, and a whole bunch of other stuff. Without further ado, let's go ahead and learn this awesome database called Postgres. Alright, in this video, let's go ahead and learn what exactly is a database. A database is a place where you can store, manipulate, and retrieve data. So usually this data is often stored inside of a computer server. So basically you put data into it and then you can retrieve, you can see data, you can manipulate, you can delete, you can update, all of the operations provided by the actual database. So let me show you a quick example of where you might see, data coming from a database. We all know Facebook, right? So Facebook is a place where we can connect with different people from all around the world. So with Facebook, they actually store a lot of information about us, and the data that they store about us is in a database, right? So for example, our names, our friends, our likes, everything is stored in a database. And then once you actually consume or you go to someone else's page and view all the comments, so on and so forth, so all of that data is coming from a database. The same with eBay, right? So if I show you this product right here, you can see that you've got a title, you've got how many sold, you've got the price. If I scroll down, you've got the description right here. And basically all of this, so even the reviews as well, so all of this is coming from a database. They have to store this information, and then anyone visiting this page can see this data. So to summarize, a database is just a place where you can store, manipulate, and retrieve data. Let's go ahead and learn exactly what PostgreSQL means. So Postgres is the actual database engine, and then SQL is the actual structured query language. So this structured query language allows us to work with databases. So basically interact with it. So SQL is a programming language that allows us to have commands like this. So select, where select is the actual SQL command, and then we have to specify some columns, right? And then from, and also from is a reserved keyword for SQL, and then the actual table name. So SQL allows us to manage data in a relational database essentially. And it's very easy to learn. So you saw that the syntax is simply select columns and then from and then the actual table or tables. And being easy, it doesn't mean that you can't do much with it. In contrast, it's very, very powerful. And it's been around for quite some time now, since 1974, and it's very widely used all over the internet. So it's a very essential programming language for anyone getting into programming. So the question that you might have is how this data is actually stored. So data is stored in tables, and these tables are formed by two things. It's formed by columns and rows, right? So it's just a regular table. And you might have a table, for example, called person, and you might define the columns, so the attributes of a person, as columns, right? So these are the columns. So a person might have an ID, first name, last name, gender, and age. And then the actual rows is the actual data inside of that table. So you can see that I've got Anne Smith, so she's a female, age 44. Then you can have another row, Jake Jones, so on and so forth. So you can see that we have some rows and some columns. So I've mentioned that SQL allows us to manage data in a relational database. So what a relational database is, it's simply a relation between one or more tables, right? So this is how data might be structured inside of a relational database. So you might have a table called person, and also you might have a table called car, and basically these two tables, they have a relationship between them. So a person may or may not have a car. So you can see, for example, Anne Smith, she doesn't have a car. So the car underscore ID column is blank. But if you look at Jake and Julia, they have a corresponding car that points to the car table. And this is what a relationship is made of. And don't worry, we're going to cover lots of this throughout this course, but so that you are aware, a relational database is when two or more tables have some kind of relationship between them. Because usually, in these databases, you have lots of information to store, right? And what you don't want to do is actually have unstructured tables where you pretty much have a table that stores everything, and then it makes it very difficult to manage, to query, and perform other operations. So what you would do is actually split, your information into tables, and then have some kind of relationship between them. Alright, so the database that you're going to be learning in this course, it's called PostgreSQL, and basically is the most advanced open source relational database out there. It's very popular because it's open source, and it's been active in development for about 30 years. So you can see right here. And basically, it's very, very popular, reliable, and a lot of new startups do use Postgres instead of using some other database engines such as Oracle, because they don't have to pay for a license. right? So this is one of the advantages over Oracle, and this is why I chose to teach you PostgreSQL, because I think that you will be in a good place once you learn PostgreSQL or simply Postgres. So as you saw, Postgres is an object relational database management system. So it allows us to work with relational databases. It's modern and it's open source. So, I'm not just saying that Postgres, it's amazing because it's open source and it's been there for about 30 plus years in active development, but you have other options such as Oracle, which you have to have a license for it, and MySQL, which is owned by Oracle, and then you have SQL Server owned by Microsoft, and pretty much you have tons of these database engines that you can pick from. But I'm teaching you the most popular one, which is Postgres. Alright, from now on, we're just going to be coding. But first, what we need to do together is download PostgreSQL. So if you are on a Mac, the easiest way to download Postgres is simply by going to google.com and then search for Postgres and then app. So for Windows, I'm going to show you guys exactly how to download this in a second. But if you're on a Mac, let's go ahead and download Postgres app. And then right here, so if I scroll down, you can see that they've got some ways on how to connect depending on a language that you use. But essentially what we need to do is go to downloads, and what we're going to do is right here you see that they have additional releases. So right here they have the Postgres 9.5, 9.6, 10 and 11. So pretty much if you download this additional releases version right here, it means that you can spin up all of these databases with these 3 or actually 4 versions. If you download the very first one, you can only spin up a database with Postgres 11. So go ahead and download the additional releases. Just give it a second. So that's done now. Click on it. Then I'm going to drag this into applications. So just let me drag that and use my password. There we go. There we go. That's done. So I'm going to close this. Now go to Finder and then Applications. And you should see Postgres right here. So what I'm going to do is simply click on it. Close that. And also let me eject this. So I'm going to eject that. So open. And there you go. So you can see that we have Postgres 11 right here. So if you click on this button right here, you can expand that. And basically, if you click on the plus button right here, you can see that you can pick from all these 4 versions that we downloaded. So this is what I was saying, that you can pick from these versions right here. So I'm going to cancel out of that. And basically, I'm going to be using Postgres 11 as I speak. But everything that we're going to cover in this course will work with the previous versions of Postgres. So now the only thing left to do is simply to start your server if it's not up and running. So I'm going to stop that, and actually you can see right here. So you can start the server. There we go. It's running. And basically right here, you can see that you have the same settings. So you can click on this elephant icon right here and you can stop, and you can also start your server from here. This is it. So now you have Postgres 11 up and running in your machine. Let's go ahead and download Postgres on Windows. So open up Google and pretty much just type Postgres and then download. And go ahead and click on this very first link. And right here, you can see that you can pick from different operating systems. And we want to download for Windows. So go ahead and pick Windows. Then go ahead and click on download the installer. And in this page right here, you can see that you can pick from different versions. So you have Postgres 11, 10, 9.6, 9.5, 9.4, and 9.3, which is not supported. So go ahead and download the latest version. So in my case, I've got 11.2. So if you have 11.2 or above, go ahead and download because everything will work the same. So I'm going to download 11.2, the 64-bit version for Windows. There we go. So now I'm going to save this and I'm going to open that in my desktop. So now what I'm going to do is simply double click on this installer. All right, so now go ahead and press next. And then next, leave the installation folder as it is. And right here, you can see that we have some check boxes. So the first one is the actual SQL server, right? So this is the actual server. Then we have the PG admin. So this is the graphical user interface client, stack builder. So this is for additional drivers. And then we have the command line tools. So go ahead and select all of those and then next. And right here, add a password for the super user. And remember this password because you're going to need it later for connecting to your database. Then next, and then leave the default port as 5432, next, and the same for locale. Go ahead and press next, and now you can see that it's installing Postgres on my machine. So just give that a second. And there we go. So that's it, we are done. So now uncheck the checkbox right there because we don't need to do anything extra with Stack Builder. So go ahead and press or actually untick that box and then finish. There we go. Now go ahead and click on Windows icon and then search for the letter P, so Postgres, and you can see that we have 11, and inside we have the PSQL. So I'm going to grab that and put that in my desktop, and the same for pgadmin 4. So that's the graphical user interface client. So just let me drag that. There we go, and let me put them right next to each other. And that's it. You successfully managed to download Postgres on Windows. Now that we have our database up and running, we need a way to connect to it. Remember, our computer is serving as a computer server, i.e. a database server really, and basically anyone can connect to it and view the contents, modify contents, and perform all the operations supported by the database. Now, the very first way that we can connect to the database is by using a GUI client. And this is an application where it eases the way that you connect to the database, and it makes your life easy in terms of performing, inserts into the database, deletes, view the data, and have like all these fancy UI elements that allows you to see your database in a much easier way. The second way is by using the terminal or command line, and this is my preferred choice. And this is because this is how you get your hands dirty by learning all the commands that your database of choice requires you to learn in order to manipulate your database. And once you learn how to use a terminal or a command line, which is not difficult to be honest, then using a GUI client is very trivial. And the third way is by using an application. So this is where, for example, you write a server-side application where you connect to your database and then you can perform data and then return that data to your client so that the client can make the data look nice on a screen or a mobile application. So let me quickly show you the actual GUI clients out there. But for this course, we're going to focus on using terminal because this is how you will master any database. And also, if you ever need to SSH into a remote server, then you will be very comfortable using the terminal or command line because you're not going to have any GUI client, to be honest. So let me show you the actual clients out there and what are some of the options that you can use if you were to use a GUI client. So DataGrip is by far one of the best database clients, and basically you can connect to any of these databases. So right here you see Postgres, MySQL, Oracle, SQL Server, Sybase, MariaDB, so on and so forth. So it's very, very cool, and you can see right here the UI is very slick, and basically it makes it easy for you to see the data, perform alterations, inserts, updates, deletes, so on and so forth. But for this application, you need to buy a license. However, you have a 30-day trial, but once that's over, you need to buy, and the price is about $149 per year. So for those on a budget, you can use Postico. So Postico is a similar tool, but less powerful. And essentially this tool is actually just for Mac users only. So this tool is free, you can download, it's amazing, and it pretty much allows you to get your job done. And for Windows users, you can download PG Admin, which does the same thing as Postico, but the UI is not as nicer as the other ones. So as I said, learning how to use the terminal or command line is not scary at all. And I want to make sure to make it super easy for you. And by the end of this course, you will be so comfortable using terminal or command line if you're already not. Alright, for Mac users, the way that you connect to your database is by simply open up this elephant icon, making sure that your database is up and running. Then click on Open Postgres, and right here you see that you have 3 databases by default. So pretty much just click on any of these, and you can see that my iTerm or terminal actually did open. And if I make this bigger, so right here you can see that we are inside of this database mode. So this was the actual command that was invoked. So applications, Postgres app, contents, versions 11, and then bin, and then PSQL. So this was the command invoked. And then -p for the port 5432, -d, and then this stands for database Postgres. So if I open up the elephant and then open Postgres, so you see that Postgres is the actual database. And if I go to server settings, you see that it's running on port 5432. Now I'm going to come out of that and then close this. Now if I open up a new shell and then type PSQL, you will see that the command was not found. And this is because we need to add it to the path. So to do so, I'm going to simply edit my path, and this assumes that you are using iTerm as well as MySQL. If not, simply add it to your bash profile. So just let me close everything here and then quit terminal. And now I'm going to open iTerm, and now I'm going to type cd and then tilde. And if I do ls -a, you can see that I have few files in here, but the one that I'm interested is this one here. So .zshrc. So I'm going to do vi and then .zshrc, just like that. So now I need to add the export right here. So I'm going to press I and then simply say export and then path equals to and then $, and then path /, and if I go back to open Postgres and then open it again, so you see that I'm after this path right here. So I'm going to grab all of that, Command C, and then go back, and then this should be column and then /, and then paste that in. And we don't need the actual PSQL. So just let me add a space right there, and then remove that. And then to escape out of that, simply press escape and then colon WQ. There we go. So now if I say source, so to pick up the changes I made in ZSHRC, there we go. So if I now clear the screen, Command L, and then simply type PSQL, you see that we have PSQL working without having to specify the full path. Alright, so previously you installed Postgres on Windows, and remember that we added these two icons. So pgadmin, so this is the actual graphical user interface client, and then PSQL, so this is the interactive shell. In this video, let's go ahead and get the database server up and running. So as I mentioned before, the best way for learning any database is by using the actual shell command line. And basically that's what we're going to do throughout this course. So first, let me go ahead and show you how to connect to your database with PSQL, and then I'm going to show you also how to use pgadmin, which is a graphical user interface, which I personally don't use, and you will see that it's not the same. So go ahead and click on this shell, so this shortcut, so PSQL. And right here you can see that it's prompting you to enter a server. So if you were to connect to a remote server, this is where you would add the actual URL. But because we are testing things locally, we will connect to our local server. So go ahead and press enter, and this will accept the defaults. Now by default, Postgres ships with a database called Postgres. So go ahead and also press enter. The port, so the default port for Postgres is 5432, enter, and then the username is also Postgres. So go ahead and press enter. And now remember that previously we added a password. So this is when we actually use it. So go ahead and use the password that you entered when you configured. So I've added mine, enter, and there we go. So now you can see that we are connected. So if I close this, so I'm going to close this and then open that again. And let's say that we want to connect to localhost again, and then let's actually connect to a database that doesn't exist. So let's go ahead and connect to test, for example. So press enter, same port, username, and then the password. If I press enter, you see that database test does not exist, right? So this is all. So this is how you connect to your local database. So let me go ahead and connect to it one last time. And there you go. So now I'm inside of this database. Finally, let me go ahead and show you also how to connect to your database using pgadmin. So this is the graphical user interface client. I'm going to click on this icon. Just give it a second. And there we go. And you can see that on the top left corner, we have servers. So I'm going to open that up. And then we have PostgreSQL 11. So go ahead and click on that. And now you can see that it's prompting us for a password. So enter the same password. And my one was actually password. So obviously you would pick something way stronger than this. But my one was pass and then word, like that. And I'm going to go ahead and save the password so that I don't have to enter every single time. Now I'll go ahead and press OK. And there we go. So now you are connected. And you can see that we have one database right here. So databases, this is the actual Postgres database, right? So this is the database. And then if I open up Postgres, you can see that there is a lot going on. But don't worry, because we're going to cover some of these things throughout this course. And this is pretty much how you connect to your database using pgadmin, which is the graphical user interface client for Windows. So as I said, throughout this course, we're not going to be using any graphical user interface client, but instead we're going to be using this shell, right? So PSQL. And because I'm going to be teaching this course on a Mac computer, the commands that I show you will actually be the exact same thing for Windows, because I'm going to be using PSQL as well. Alright, so in the previous video, we managed to add PSQL to the path. So now we can simply type PSQL and there we go. So just let me quit out of this, and basically if you type PSQL, you should go into this mode right here where you see that, using PSQL, the version is 11, and if you need help, you can type help. So help, and there we go. So you see that we get some help. Now, basically every single command right here starts with a backslash. So if I want to quit out of this mode, I can simply type backslash and then Q, and then as you can see, I'm no longer in the actual PSQL mode. So let me go ahead and simply type PSQL again, and if I clear out of that, and then if I simply type backslash and then question mark, you see that I get more help. And basically there is a bunch of things that we're going to cover in this course. So let me go ahead and press Q, and if I press help again, if I press backslash and then L and then press enter, you see that this command simply lists all of the databases that we have in our computer. So right here you see that I've got 4 databases: Amigos Code, Postgres, Template 0, and then Template 1. So by default these are generated for us, but we can create our own database. To do so, we need to use a command that creates a fresh database that we can then create all the tables inside of this database. And to do so, we need to use the command create and then database, and then we have to give it a name. So this database must have a name. So the name can be anything you want, but what comes before it, meaning create database, must be exactly like that. So you can either use lowercase or uppercase. So you can say create and then database. I personally prefer the database way because that way I know what is SQL syntax and what is not. So I'm going to use uppercase, so create and then database. And then the name of this database will be test. And then make sure to end that with a semicolon, because otherwise it won't execute the command. So I'm going to press enter, and you see that we have this response back which says create database. Now to view the list of all databases, simply press backslash and then L, enter, and right here you can see that this is the database that we've just created. Alright, so in this video I'm going to show you how to connect to databases, and there are 2 ways. The first one is if I type PSQL, and please follow along because this is the way that you will learn. So PSQL and then dash and then help. So right here you see that we get a bunch of help. So these are the usages. So you can see that you type PSQL and then some options, and then the actual DB name followed by the username. So right here you see that for database name you simply type -d, and if I scroll down, so you can see that these are the connection options. So the host is minus, or actually -h or --host equals to host name. The same for port is -p, and then -U for username or --username. -w, or actually -w, and then capital W for no password. So let's give it a go. So PSQL and then dash and then H, and then the host will be localhost. But if you were connecting to a remote server, then you would type the actual IP address and then dash and then U for the actual username. So amigos and then code. And by default, you can see that the actual username is amigos code. So before actually giving the username, I'm going to say dash and then P, and this is the actual port. So by default, our database is running on port 5432, and that's the default by Postgres. And then we can specify the actual database name. So our database was called test, and if I press enter, you can see that we are connected into the test database. If I was to quit out of that and then write the same command, but let's say that we want to connect to a database that doesn't exist, so test1, enter, you see that we get this PSQL fatal error saying that the database test1 does not exist. The same for, let's say, the actual user, so amigos codes with multiple S's. Enter, you see that the role doesn't exist, and the same for the actual port. So if I add a 1 there, enter, you see that the connection was refused. So let's go ahead and connect to test. And there we go. So now we are inside of the test database. So this is one way to connect to this database called test. The other way is if I press / and then Q to exit and then clear the screen, I can type PSQL and then I can do / and then L. So this lists the databases. And by the way, if you've missed where I got this / L command, is from PSQL -- help. And at the very top, you see that you can list the available databases. So I'm going to press Q and then PSQL, clear the screen, and then / L. So now you see that I do have this database called test. Now the way that we can connect from here is simply by saying / and then C for connect, and then I can type test, enter, and you can see that now we are connected to the database test as user amigos code. If I want to connect to a different database, so let's say that we want to connect to this database called amigos code, simply type C and then amigos, press tab, and that auto completes for you, and then enter, and there we go. So we can switch between databases just like so. So Postgres, enter, and there we go. So let me go ahead and connect to test because this is the database that we're going to be using. And there we go. And these are the ways that you can connect to any database. Alright, in this video I want to share with you a very important command that you should be aware of, and you should take extra careful when using it. So in the previous video I've showed you how to create this database called test, and let's say that for some reason you want to get rid of this database called test, i.e. delete. So to create a database, you simply say create and then database, and then you give it a name, in our case test. To delete a database, you simply say drop and then database and then the actual name. So, and also make sure to end that with a semicolon. I'm not just going to run it yet because I want to stress out why this is very dangerous. So it's dangerous because let's say that you have this database called test with 5 or 10 years worth of history. So that could be, if you have a business, that could be, for example, customer information, addresses, emails, the transactions that they made, login credentials, so on and so forth. So if you were to run this command on that database, this means that all of its content is lost in a matter of milliseconds. Really, it's just that quick. So when you have, for example, a production application and you log in or SSH into your box, you should never run this command because you will lose pretty much every single data in it. And often if you SSH or log in into a remote database, then you should have access or some kind of monitoring to see what people are allowed to do. And because I'm teaching you Postgres, it's absolutely fine for us to experiment with this command. After all, we don't have any important data in that database, right? So let me go ahead and press enter, and you can see that the database is gone in a matter of milliseconds. Let me go ahead and press backslash and then L, and you can see that the database is gone. So no data in it. So often as well, if you have one database, you have to make sure that you have a backup of your data in case of any eventual accidentally loss of information. So let's go ahead and recreate this database because we're going to need it throughout this course. So create an end database and then test. And make sure to end that with a semicolon, otherwise the command won't execute. So I'm going to press enter. And if I go ahead and press Ctrl L and then backslash and then L, you can see that we have our database back again. So the point of this video was really to stress out how dangerous it is to execute any kind of drop command. Alright, in this video I'm going to show you how to create your very first table with Postgres. So to create a table, you need to write a command such as this one. Create table, so this is pure SQL, and then you define the actual table name, and then inside of parentheses you can have as many columns as you want. So the columns have few attributes. So the very first one that you must have is column name, and then the second one that you also must have is the data type. So the data type for that column name. And then if you have any constraints, you should also specify them. So I'm going to explain what this means in a second, but for now, let's say that you want to represent people in your database. So you would have a table like this. So you have a table called person, so you would write create table person, and then inside you see that I define the actual columns that this table called person has. So the first one is ID, and the data type of it is int, so integer, meaning that it's numbers. And then I have first name, which is varchar. So varchar is pretty much just characters, and then 50 means that the maximum length that this column called first name can have is 50 characters long. The same for last name. Then I also have a column called gender, and this as well is varchar, so characters up to length 6, and then I have date of birth, and the data type is timestamp. Maybe we don't actually need a timestamp because timestamp includes the full date, including hour, minutes, and seconds. So maybe we can use a date instead of timestamp, but I'm going to show you that in a second. So this is it. So let me show you a list of all data types that you might encounter with Postgres. This is the documentation for data types within Postgres. I'm going to leave a link in the description below so you can access this page. But if I scroll down, you can see that you have a bunch of information, so table of contents. So just let me scroll down because it will be easier for you to see right here. So you can see that the data types that you have can be big int. So this is a signed 8-byte integer, big serial, booleans for true or false. You have characters, you have varchar. So this is the alias that I was using. And then you have date. So this is the one that we should actually use for date of birth. So as you can see, it only contains year, month, and then the actual date. And then you have double, you have JSON, you have money. So this is when dealing with money. So any currency amount. You have numeric, so for decimal, so this is the actual alias, so you can say numeric or decimal. And then you have some other ones, so you have like small int, you have serial. So serial is a 4-byte integer, but this is special because it auto increments automatically for you. So I'm going to show you how to use that in a second as well. And then you have text. So when you have text, there is no max length. And then you have others such as time and then timestamp. So right here, you can see that the timestamp contains the actual date plus hour, minutes, and seconds, and plus the actual milliseconds. And then you also have viewed, which is a good one for IDs. And then you can also have XML data. So go ahead and navigate to this page to familiarize yourself with all of these data types. Let's go ahead and connect to our database called test and create our very first table. So I'm going to go ahead and press backslash and then C for connect and then test and then enter. You can see that I'm now connected to database test as user Amigos code. So let me go ahead and clear the screen. So Control L. And to create our very first table, we need to write this command that I've showed you previously. So just let me open the docs, or actually the slides, so that you remember exactly what I have mentioned in the previous video. So create table, the name, and then the actual columns. So in uppercase for SQL commands, create and then table, and then the actual name was person, and remember this was singular, and then open parentheses. And now if I press enter, this command won't be executed until I end up with a semicolon. So now let's go ahead and have our very first column called ID. And this was int, so uppercase int. And then we also had the first name, and this was var char and then 50. We also had last name, and this was var char 52. We also had gender, and this was var char, and I think it was 6 or 7, but let's go ahead with 7. And then let's go ahead and finally have the actual date of birth, so date of and then birth. And we said that instead of timestamp, right, because we don't really know, the time of when someone, gives birth, we don't usually store that information. So let's go ahead and have the data type as date. And I'm going to end that with a parenthesis. So open parenthesis, close parenthesis, and then end that with a semicolon. So if I now execute this command, so press enter, you see that we have a table. Now, the way that we see the list of all the tables that we have in our database is simply by pressing backslash and then D. So D for describe. So if I press backslash D, you can see that we have one table called person, and you can see the type is table. Now we can even go one step further, and that is to describe the actual table name, so person. If I press enter, and now you can see that we have one table called person, and the columns are ID, first name, last name, gender, and date of birth. And you can see the type, so the data type, integer, characters, and then date right here. And there is some extra information, so nullable, so these are like constraints. And you can also have default values when you create a record in this table. And this is how you create a table using Postgres. So in the previous video, we created the above table without any constraints whatsoever. So basically what we can do is specify some extra constraint into our table creation to enforce that before someone inserts a new record into this table, it must satisfy these constraints. Because currently in our table called person, we can go ahead and pretty much just create a person without an ID, without first name, without last name, without gender, and also without date of birth. So what is the point of having a person without any of this information? So to improve on that, what we can do is simply specify the actual constraint. So on the table below, you can see that the ID becomes now big serial. So this is an improvement because big serials do increment by themselves. And then I'm saying that this column must not be null. So not null. And I'm also specifying that the ID is the primary key for this table. So the ID is what uniquely identifies a person in the actual table. So the same for first name. So what I'm saying is not null. So if you want to insert a person into this table, you should specify the first name, last name, gender, as well as date of birth. Let's go ahead and improve our table with these constraints. So what I'm going to do is go back to iterm or command line if you are on Windows. And remember, a few videos ago, I showed you how to drop a database. We can also drop tables. Again, you have to be very careful when you perform this operation, but because I'm showing you how to improve this table, we can pretty much drop it and we don't have any data in it as well. So go ahead and simply say drop and then table, and then the table name is called person. Enter. If I now do backslash and then D, you see that did not find any relations. So let's go ahead and improve on the actual table creation. So let me just clear everything. And let's go ahead and say create and then table and then person, parentheses, and then inside, let's go ahead and have ID. This will be big and then serial. So big serial means that it's a signed integer which auto increments. So big serial, and then this will be not null. So we must have one of these, and then primary key. So all of this is SQL syntax. Let's go ahead and do pretty much the same for first name, var char, and then this will be 50. Well, actually, I do have a mistake, so I forgot to add not null. So I'm going to press column, and this should break out. So actually, not column, so end that like that. And let's go ahead and recreate this. There we go. So now not and then null. Enter. Let's go ahead and grab last name there. And then this should be not and then null. And let's grab the actual gender. So gender, this was var char and then 7, I believe. And then this will be not null. And let's also have the actual date of birth, date, and then this also must be not null. So you might be saying, okay, Nelson, so everything is not null. When should a column be nullable? So when a new person is added to this table, they may or may not have an email, right? Not everybody has an email. So we can go ahead and add another column called email. And this will be, let's go ahead and say var and then char. And this will be, something a bit bigger. So let's go ahead and say 150 characters. And if I say not null, so this is not true because some people don't have an email. So I'm going to leave this column as nullable. So now I'm going to end that with parentheses and also end that with semicolon. If I now press enter, you can see that we have our table. If I Control L to clear the screen and then backslash D, you see that we have this person right here, but we also have this person ID sequence. And the reason why we have this sequence is because of the big serial that we created. So big serial, as I mentioned, is an auto increment number. So we don't have to keep on remembering the previous number. So if I go to the docs, and then you can see that right here, if I can find it. So right here, auto increment 8-byte integer. So this person ID sequence is not a table, and you can see right here, it's simply a sequence. So we can go ahead and simply say / or actually \, and then D, and then person, and then enter. And now look at this. So our table is much better because we have these constraints right here. So not null, for ID, for first name, last name, gender, and date of birth. And also the actual email, so this email right here is because not everybody has an email, so it is nullable. In this video, let's go ahead and learn how to insert records into tables. So far, we have a database called test with one table called person with the following columns: ID, first name, last name, gender, date of birth, and email. So let's say that we want to insert a new person into this table. So the person will have the ID of 1, name Anne, last name Smith, gender female, and the following date of birth, the 9th of January of 1980, and this person does not have an email. So to create this person into our table, we have to write the following command: insert into, and then the actual table name, and then we have to specify the columns that we want to insert. In this case, first name, last name, gender, and date of birth. So remember, this person does not have an email. Therefore, we don't have to specify the email column. And then we have to say values. And then values takes an array of values matching the column's data types. So in our case, Anne Smith, female, and then the last column, date of birth, is actually date and not a string. So the way that you represent dates is by simply saying date, and then you have to make sure that the year comes first, then the month, and then the actual day. So there we go. So this is how you insert new records into any table. So let's now say that we want to insert a second record into this table, i.e. a second person. So let's go ahead and simply say insert into person. So insert into the actual table name called person. And then the columns that we will insert to are first name, last name, gender, date of birth. And in this case, this person has an email. So we also specify the actual email. And then we simply pass all the values. So Jake Jones, male, and then the date of birth is, the year is 1990, the month is January, and then the day is the 10th. And once we execute that command, we will get a new person with an ID of 2 into our database. So as you see, I'm not specifying the actual ID column, and this is because if you remember correctly, the big serial data type does an auto increment for us, which means that we don't have to manage this ID. So if we insert more people into this table, we simply get the ID managed for us, i.e. being auto incremented. So you'll get 1, 2, 3, and then 4, so on and so forth. Alright, so now I'm inside of PSQL, and I'm going to press \D, so lowercase d, and you can see the list of relations. So this is just to refresh your mind. So we have person and then person ID. This is the sequence for our ID. If you want to see just the tables, press \D and then T. So this shows just tables, and you can see we only have one table. So let's go ahead and insert a person into this table. So the command is insert and then into, and then the actual table name, so person, and then we have to specify the actual columns. So I'm not going to specify the ID because that's managed by us by this sequence right here, so person ID sequence. So I'm going to specify first name, last name, gender, and then date of birth. So let's say that this person does not have an email, right? And that with parentheses, and then if I press enter, this command won't be executed until you end the entire command with semicolon, if you don't remember. And then I'm going to say values, and inside parentheses the values, so it takes an array of values and they have to match the same order as the columns names specified right here. So the first name is Anne, and then the last name is Smith, so she's a female, so female, and then the date of birth is date, and then within quotes 1988, and then 01 for February, and then the 9th. So remember that first comes the year, month, and then the actual day. And then if I end that with semicolon and then enter, you see that we get this message right here, insert 01. So that means that the insert did work. Let's go ahead and pretty much just do the same command, but this time let's go ahead and add a male. So this will be male. So I've just pressed the up arrow and I got the same command, so in case you're wondering. So this is Jones, and then Jones, so this is actually Jake Jones. And if I go back, let's also specify the actual email, so email. And then if I go all the way down here, let's say that this guy is from 1990, and then let's say the 12th, and then let's say the 31st. And I also have to specify the email, so let's say that the email is Jake and then at gmail.com. If I press enter, you can see that this same command did work. And this is how you insert into tables. So far we have two people in our table, Anne, so right here, and also Jake. In this video, let's go ahead and add 1,000 more people in our table, and also add a column called country of birth. So in order for us to add 1,000 more people into our table, we're going to use this website called Mockaroo. So this is simply a data generator, and basically we can generate data in various formats. So right here you can see that we can select our fields, and basically you can then select the types and have some options. So for our table person, we going to exclude the actual ID because this is managed by the sequence for us. So we have first name, last name, and then gender, and we don't actually have the IP address. And let's go ahead and add the date and then of and then birth, and this will be date. So if you select on the type and then simply search for date, and right here we can actually specify the format, so year, month, and day. And let's also configure the actual email. So let's say that 30% of them will be null. So we want to have some people in our table with nullable email addresses, and 70% of them will actually have an email. And finally, what we need to do is add another field. So let's actually call this country of birth, and instead of date, let's go ahead and pick, I think we can pick country. So there we go, country. And I think this is good for now. So now you can see that we can generate 1,000 rows. And basically, if you want more than 1,000, you can keep on downloading 1,000 each time, or you can actually sign up and then you can generate more than 1,000 rows. So 1,000 for us is fine for this course. And the format, go ahead and change that to SQL, but you can see that they have XML, Firebase, Cassandra, JSON, so on and so forth. So go ahead and pick SQL, and then the actual table name. So let's actually change this to person. And what we're going to do is actually include the create table. Now go ahead and preview, and you can see that the data contains a bunch of random people, some with email and others without email. And if you click on the SQL, you can see that we have a bunch of inserts. And right here we have the actual create table. So you've learned this in the previous videos. So now let's go ahead and close out of that and then simply download the data. I want to download. There we go. So now we have this person.sql, and to open this file, I'm going to be using VS Code. So VS Code for me is the best IDE out there for working with SQL files and pretty much like with web development as well. So this is the one to go. But if I'm doing like more backend server side work, then I use IntelliJ. So you can use VS Code or Atom. So Atom is actually good as well. Atom. Or you can use Sublime. So go ahead and pick your favorite IDE. But for this course, I'm going to be using VS Code. So I'm going to open that file with VS Code. So I'm going to open VS Code and then File and then Open. And then inside of Downloads, this is my person.sql. And there we go. So now you can see that we have the create table. So you've learned about this, and also you learned how to insert into tables. So insert into person, first name, last name, email, gender, date of birth, and also our new column called country of birth. And then you can see all the values. So there is one change that we have to do, and that is to make these fields nullables. So I'm going to select those commas right there, and then I'm going to say not and then null, apart from the actual email. Remember, the email is nullable. And also let's go ahead and increase the actual size of the email. So let's say 100, or actually 150, and then the gender should be actually 7. And country of birth, I think 50 should be fine. So I'm going to save this. Now we could actually grab everything, so copy and paste into our terminal and then execute all of these statements. But what we're going to do is something much more clever than that. So go back to your terminal or command line, and basically if you press backslash and then question mark, you can see that if I go a bit down, so you can see right here in the input and output section, we have this command right here, \i, and then you specify the actual file. So this executes commands from a file. Now I'm going to come out of that and then open up a new shell. And if I make this bigger, so what you need to do is to actually navigate to your downloads or whatever you save the file. So I'm going to navigate to documents, or actually it was downloads. So downloads, there you go. And now if I do an LA, you can see that we have person.sql right here. And to get the actual path, I simply have to type pwd, and you can see that the path is users, amigos code, and then download. So I'm going to grab all of that. So command C, go back to my main shell, and now we can go ahead and execute that file. So let's go ahead and press backslash and then I, and then paste the actual file destination, / and then person.sql. If I now press enter, you see that we get errors, and the error is that the country of birth of relation person does not exist, and that's correct. So if I clear the screen and then do a backslash and then D and then person, you can see that we don't have the country of birth column right here. So let's go ahead and drop this table. That's right, drop. And as I've mentioned before, using the drop command, it's not ideal, but because I'm just teaching you how to use new commands, and this is just for illustration purposes, it's absolutely fine. But if you have a production database, do not run this command. So to drop a table, simply say drop and then table and then the table name, so person. So if I execute this, all the data that we have, which is 2 students, will disappear, as well as the actual table. So if I press enter, if I press \D, you see that did not find any relations. So I'm going to clear the screen and now press up a couple of times, and we're going to execute the same command. So \I, the destination to the actual file, and then the file, so person.sql. If I press enter now, and you can see that we have a bunch of inserts and everything worked as expected. Now if I clear the screen and then type select and then star from and then person, semicolon, and then enter, and there we go. So you can see that now if I make this smaller, so full screen there, you can see that now we have a bunch of random data. But there is one thing that we forgot, and that's the actual ID. So let's actually fix that. Q, and then go back to the actual person.sql, and to fix it is very easy. So let's simply add ID, and this will be a big serial. So we had a big serial, and this was not and then null, and it was also the primary and then key. So now if I save this, remember we don't have to add it here because the big serial will manage that for us with a sequence. So what we need to do is actually go back to iterm. So let's again drop the table. So drop table and then person. There you go. And now let's run the same command. So \I and then the file, enter. There we go. So that worked. If I clear the screen and then select all from person, enter, and there we go. So now we have our ID back, and we have a bunch of people into this new table. There we go. So I just wanted to show you how to drop tables and pretty much just add a new column called country of birth to use it for selection purposes. Alright, so let's go ahead and read all the records stored in our person table. So to grab the records from this table, we have to issue this SQL command. So we have to say select, and we're going to select star. So I'm going to explain what star means in a second, and then say from, and then the actual table name, so person, and that with a semicolon. So if I clear the screen first and then run this command, you can see that we get 2 people in our table. So first you can see that we have Anne, and then we have Jake, and the ID is actually managed by the sequence, so 1 and then 2. So the actual star keyword, so select star, means that you want to select every single column from this table. So if I was simply to say select and then nothing, so select from person and then enter, you see that we get 2 rows, but we haven't selected anything. So I can go ahead and say select, and then for example first name and then from person, and that with a semicolon. And if I press enter, now you can see that we only got back Anne and Jake. So we simply selected the first column. Let's go ahead and select first and last name. So select first name, and then if you want a second column, go ahead and press comma and then say second and then name. There we go. So if I press enter, oh actually second name doesn't exist, so it should be last name, my bad. Enter, and you can see that we have Anne and then Smith, Jake and then Jones. Now let's go ahead and select email to see what happens if we select someone that doesn't have an email. So I'm going to do select. I'm going to say from person. If I press enter, you can see that the first row is empty, right? So it doesn't have a value, and that's true because she didn't have an email right here. So if I now scroll down and let me simply go ahead and say select. So just let me press up a couple of times. So select start from person. There we go. And this is how you perform the very basic read operation, which is selecting everyone from this table. In this video, let's go ahead and learn how to sort our data using the order by keyword. So the order by keyword takes a column and then orders the results that we get back by ascending order or descending. So ascending means that if you have numbers is 1, 2, 3, 4, 5, and this is ascending. So you can see that the numbers are increasing. Well, descending is 5, 4, 3, 2, 1, and you can see that this is descending. And these are the actual keywords that we use in conjunction with order by. So let's go ahead and pretty much just do a select star and then from person. And then if we want to order by the actual country, so we can say order and then by and then country of and then birth. And by default, the way that this statement will be sorted is by ascending order. So I can even include ascending or leave it like that. So just let me show you. So if I press enter, or actually I've misspelled country. There we go. Press enter again. And now you can see that the results that we get back are sorted by the actual country. So in ascending order, meaning A and then B, C, D, so on and so forth. So basically ascending and descending, they both work for dates, numbers, and strings. So let's go ahead and quit out of this. So remember I said that the default is ascending. So if I include ascending, you can see that the results are the same. If I press Q and then go back, and now let's reverse the order. So descending, meaning from Z to A. If I press enter, you can see that now the results are sorted from the last letter of the alphabet to A. So if I press Q, we can actually sort by the actual ID. So if I do ID, press enter, you can see that it goes from 1,999 all the way to 1. And then if I reverse this, so ascending, it goes from 1, 2, 3, 4, 5, 6, 7. So if I press Q, let's also order by the actual first name. You can see we go all the A's first. Let's go ahead and do descending. You can see that we have all the Z's first. So we can also sort by the email. So instead of first name, we're not going to do last name because it's the same as first name. So email and then descending, enter. You can see that first we get all the nulls, right? So the nulls, because these are empty. And then if I keep on scrolling down, so right here, so right here you can see that we have then Z, right? Z and then Y, W, so on and so forth. And basically one last thing is that you can combine multiple columns when you sort. So let's go ahead and order by the actual ID. So ID and then email. If I press enter, you can see that first we have ID 1, 2, 3, and then we also have the actual email starting from A. So basically sometimes it's a bit hard to understand exactly what's going on because you have, for example, 5 here, but then you have G and then you have C. But basically the rule is when you sort your data, use at most one column. And finally, I also forgot how to sort by the actual date of birth. So by and then date of birth. and then enter. You can see that the results are now sorted by the 1920 all the way to 2017. And if I do descending, so descending, you can see that we have 2017 first all the way down to 1920. And this is how you sort your data using order by. Let's go ahead and select the country of birth from and then person. If I press enter, you can see that, or actually let's also apply some sorting. So order and then by and then country of and then birth, and that with semicolon and then enter. And you can see that we have Afghanistan, Albania, Argentina, so on and so forth. But you can see that we have lots of duplicates, right? So, you can see like Brazil, there's quite a lot of them, and then Bulgaria, Canada, China, probably the biggest population in the world, so lots of them. So let's say that we just want to know the unique countries that we have in our table. i.e., we just want to see Afghanistan once, Albania once, Argentina once, Armenia once, so on and so forth. To do that, what we need to do is select, and then we can use the distinct, and then the distinct takes the actual column, so country of birth, and then from person, order by, and then country of birth. If I press enter, and now you can see that we have Afghanistan once, Albania once, Andorra once, Angola, so on and so forth. So I can, scroll down and you can see all the countries that we have. So 124 countries in total. So I can reverse the order as well. So if I do DESC for descending, enter, and there we go. And this is how you use the distinct keyword to remove duplicates from your query. So we use countries, but you can also use it for dates, emails, pretty much any column. Let's go ahead and learn about the where clause. So the where clause, if I close that, so where clause allows us to filter the data based on conditions. So the very basic condition that we can actually do with our table is we can go ahead and say select and then start from person, and then we can use where, so where a column or columns meet certain criteria. So we can go ahead and simply say where and then gender equals to and then female. If I end up with semicolon and then press enter, there we go. And now you can see that the results that we go back contains only female. So if I keep on going, you will see that we only have female. So I can go ahead and also say, let's go ahead and pick the actual male. So where the gender is just male. Enter, and you can see that now we only have male. So we can use the where clause to filter based on column or column. So we can actually have multiple conditions. So if I go back, so if I press Q, and then now to actually use another condition, I can go ahead and say and. So we can use the and keyword, and we can pretty much just filter, for example, where the country and then of and then birth equals, and then let's say Poland. If I press semicolon, enter, and you can see that now we have every single guy that was born in Poland. So we can also say, so we can actually combine these. So I can say country of birth equals to Poland, or, so I can say or, so in caps, or country of and then birth equals to, and then let's say China, and then end that with parentheses, enter. And I've misspelled birth wrong, so just let me go back. So this should be T and then H, and then enter. And you can see that now we have every single guy that was born either in China or Poland. There we go. So we can also filter a bit more. So let's see if we have anyone with the same last name. So I'm going to grab that last name. So Pietersma. I don't know if I spelled that correctly or not, but I'm going to press Q and then I'm going to add another and. So let me just press enter. And then last name equals to Pietersma. Sorry, it's a funny surname. So if I press semicolon and then enter, and you can see that we only have one person with that surname. So let's actually see if we have any female. Change that to female, enter, and no females with that surname. What operators allows us to do, it allows us to perform arithmetic operations, comparisons, bitwise, and logical operations. So most of the times you're going to be using arithmetic operators and comparison operators. So you still have the bitwise and logical operators, but basically I often don't use those unless I'm doing something very complex. But for most of the time, you're going to be using the comparison as well as the arithmetic operators. So let's go ahead and learn about the comparisons. So basically, if I go ahead and say select, and then you can say select 1, and now pretty much just type equal and then 1. And if you end that with a semicolon and then press enter, you see that you get this column right here. This is what by default Postgres gives you, but don't worry about this for now. But basically you can see that right here you performed a select 1 equals 1, and this has given you true. So this is the comparison operator. So it allows us to perform comparisons based on certain conditions that we want, and then it will either return true or false. So let's go ahead and say 1 equals to 2, and we all know that that's false. So you can see right here it is false. We can also go ahead and say 1 is less than 2, which is true, and we can say 1 is less or equal to 2, which is also true. But if I also say 1 is less or equal, or actually let's go ahead and say less than 1, this is false. So you can see right here 1 is not less than 1. But if I also say 1 is less or equal to 1, it is also true. So you can flip the sign. So this is the less. So the way that I always remember these is that the less sign has the shape of an L. So L for less. So if you want to check whether a number is greater than another, you can simply type the opposite. So greater goes like that, and 1 is greater or equal to 1. It is also true, but 1 is not greater or equal to 2. So you can see right here, this is false. So you've seen equals, you've seen less or equal, and greater or equal. So what about if you want to check whether a number is not equal? So we could simply say select, and then the not equal is simply this diamond right here. So 1 is not equal to 2. If I press enter, you see that this is true. So let me go ahead and pretty much just type 1. So 1 is not equal to 1, and this is actually false. So 1 is equal to 1. And you see that I'm using these comparison operators on numbers, but you can also use them on strings, dates, and pretty much any data type. So I could go ahead and say select, and then amigos code, and then not equal to, and then let's simply type lowercase version amigos code. Press enter, and you can see that this is true. They are not equal. But if I was to capitalize the second one, so amigos code, and then press enter, you can see that now this is false. So I could also go ahead and pretty much just use the equal, and you can see that it's true. If I type a nest down there, it is false. And this is how you use comparison operators. And basically you can use these comparisons operators to filter down your data in the where clause. Alright, in this video, let's go ahead and learn about the limit keyword as well as the offset. So let's say that we simply want to select the very first 10 rows from this table. So what we can do is simply say select star and then use the limit keyword. So I can say limit and then 10. So basically this can be any value. So what you're saying is you want to limit the results returned by this select query right here. So select star, and you simply want to limit by 10 records. If I press enter, you can see that we have the very first 10 people in this table. So I can go ahead and simply say select. So if I clear that and then select and then star from person, limit, and then 5. So you can see that we only have the first 5. But we can also offset the actual limit. Let's say that you want to select the very first 5 people after this row right here. So to do that, you can use the offset keyword. So you can say select and then star from person, offset 5 rows, and then limit 5. So press semicolon, and now you see that we get everyone from 6 up to 10. So I could actually go ahead and remove the limit. So this would pick everyone starting from row 5, or actually row 6, all the way to the last one. So if I press enter, you see that it starts from 6. Now there is another keyword that allows us to perform the same thing as the limit. So limit is not a keyword by SQL standards. So it was actually widely used by different other databases, and then it became a thing. But the official way of actually limiting the results coming from a query is by using the fetch keyword. So we can go ahead and say the same thing. So select star from and then person. Let's offset this by 5, and then you can say fetch and then the number of rows. So let's say that we want to select the first and then 5 and then row only. If I press semicolon and then run it, and you can see that we get the same thing. So I can go ahead and pretty much just select the first row. So all I need to do is just say first and then 1 row, or I can simply just remove 1. So this is the same thing. And basically this is the same thing as using the limit, but this is a SQL standard. Let's say that we want to select everyone from China. So we have China right here, and let's say Brazil, and then France. So we could write a SQL like this. So select and then star from and then person, where, and then country of birth equals to China, or in fact, let me put this on a new line. So or country of birth equals to France, and finally or country of birth equals to Brazil. And if I press enter, you can see that we get everyone from China, France, and Brazil only. So this was actually a lot of code just to include China, France, and Brazil. And you can see that we are duplicating country of birth 3 times. So one there, another one here, and another one there. So to improve on this, we can use the in keyword. So in keyword takes an array of values and then returns a query matching those values. So let's go ahead and improve this query with in keyword. So select and then star and then from, well actually let me put it on this line. So from and then person, and then you can say where country of birth in, and within parentheses, this is where you pass your values. So China, Brazil, and finally France. And this is the exact same thing that we had up here. So right here. So if I press semicolon, run the command, and you can see that we get everyone from China, France, and Brazil only. So this makes it easy to add other countries, comma, and let's also include Mexico, and let's also include Portugal, and one more. So let's say Nigeria. If I press enter, there we go. So you can see that we have China, France, Brazil, Mexico, Portugal. And to make this easy, let's go ahead and remove that and say order and then by country of birth and then semicolon, enter. Now you can see that we have Brazil and then China. So there's quite a lot of Chinese in this table, and then France and Mexico right here, and then you can see Nigeria, so only few people from Nigeria, and then Portugal. In this video, let's go ahead and use the between keyword to select data from a range. So let's say that we want to find out everyone that was born between 2000 and 2015, for example. So we could do that using the between keyword, and basically it goes like this: select star from. So if I put this on a new line, and then I need to use the where, so where and then date of and then birth. And now I'm going to use the between keyword, so between. So basically I'm saying select everyone between, so let's go ahead and say date. So this is a SQL function. So remember, dates, they start with the actual year. So I said 2000, so 0101, and then and, so this is the actual end. So let me explain this in a second. So 2015, I said 0101. So basically I'm saying select everyone from person where the date of birth between these two dates. So this is the start, and then you have to specify the end. If I press enter, and this should be between, not between. So I'm just missing a T right there, and then enter. And there we go. This is how you select from a range where you specify the start and then the end. So in this result right here, you will not find someone which has a date of birth less than 2000 and someone that has a date of birth bigger than 2015. Alright, in this video, let's go ahead and learn about the like operator. So the like operator is used to match text values against a pattern using wildcards. So I think it's best for me to show it in action, and then you will understand it right away. So let's say that we have, this list of emails right here. So these emails right here, and we want to find every single email that ends in .com. So the way that we do that with the like keyword is simply by saying select person, or actually select star from person, and then where, and then you specify the column name, so email, and then you can say email like, and then within quotes you specify the actual pattern. Now I can do any character, so the wildcard simply says any character followed by .com. If I end up with semicolon, enter, and you can see that I only get emails ending in .com. Let's say that we want to find if there is anybody with Bloomberg.com email. So let's go ahead and simply say Bloomberg, so at, and then Bloomberg, and then .com. So basically any character followed by at Bloomberg.com. Enter. You can see that we have 3 people. Let's go ahead and try and find anyone with a google.com email. So google.com, enter 3 people, but there could be a case where we have employees from Google in a different country. So for example, HK or France or any other country, right? So we can pretty much just remove the .com portion and then use another wildcard. So this simply says any character, so any character followed by @ followed by Google dot, so you can see the dot here, and then followed by anything. So this time we should include .com plus any other emails. If I press enter, you can see that this time we get a bunch of more emails from Google. So this is how you use the wildcard. So basically you specify any characters preceding your pattern, or any characters before whatever pattern you specify, as you saw right here. Now there are 2 things I want to show you. So one is, instead of using the actual wildcard, we can use underscore. So underscore simply says that this has to match single characters. So let's say that I've got 1, 2, 3, 4, 5, 6, 7, 8 characters, and then followed by @ and then if I press enter, you can see that we have a bunch of emails right here. So you can count the characters, so all of them have 8 characters followed by the actual @ sign. So we could also say that let's say that we want to find any person that has at least 3 characters followed by, let's say, O, right? And then followed by @ and then anything. If I press enter, there's no one there. If I press H, let's just keep on trying. There's no one there. Let's go ahead and type that. There's no one there also. There's no one there. So basically there's no one with this pattern right here. So, but you get the point. Now there is one other thing that I want to show you, and that is a keyword called a like. So let me first run the query, and then you'll see why this is useful. So let's say that we want to find any email or any country. So let's go ahead and say country that starts with P. So P and then wildcard. So this will match P and then followed by anything. So if I run this query, or actually it's not country, so country of and then birth, you see that we get no one. But now let's go ahead and put an uppercase P right here. If I press enter, you can see that now we have Philippines, Poland, Peru, Portugal, Paraguay, Pakistan, Palestinian territories, so on and so forth, right? So you saw that I had to explicitly put an uppercase P. So the I like keyword simply ignores the case, so it's case sensitive. If I put lowercase p and then run this, you see that we get the same result. In this video, let's go ahead and learn how to use the grouping by keyword. So this is very powerful and basically allows us to group our data based on a column. So a good candidate for grouping by in our data set is the actual country. Let's say that we want to find out how many people that we have for each of the countries that we have. So if I pretty much just select and then distinct and then country of birth from person and then press enter, you see that these are all the countries that we have. So in total 124 countries. But let's say that we want to find out how many people that we have for each of these countries. For that, we can use the group by. So the group by works as follows. Select and then the actual column name. So let's go ahead and say country and then of birth. And then if I say from and then person, And then let's go ahead and say group. So this is the actual keyword. So group and then by, and then the actual column. So country of and then birth. So if I run this query, this will not work, and I'm going to explain why in a second. If I run this, you see that we pretty much just grouping by the country of code, so the country of birth, but we're not getting the actual number of people for each country. And this is because we have to select a second column. Now I will give you a second to see if you can pretty much just guess what column we need to select from here. And it's none of the columns that we've specified. Can you guess? Well, the column is actually count. So we can use count. And this is not really a column, it's just a function that counts. So let's go ahead and say star. That counts every single one from this country of birth, right? So we select the country of birth, and then it also does a count on the actual country of birth. So if I press enter, now you can see that we have Bangladesh, there is only one person, Indonesia, 96 people, Venezuela, 6 people, Cameroon, 3 people, so on and so forth. So in fact, let me go ahead and sort this. So order and then by country of birth, and then semicolon, enter, and now you can see the data organized. So Afghanistan 3, Argentina, and probably China will be the biggest one right here. So China 182, and then you can scroll down and see Indonesia 96. So they have a big population there as well, and basically that's all we have. So you know, very, very simple, but very powerful, because sometimes you want to get statistics out of your database, and this is how you use the group by keyword. Alright, in this video, let's go ahead and learn about the having keyword. So the having keyword works with group by, and basically it allows you to perform an extra filtering after you perform the aggregation. In our case, we have count, and count is simply summing up everyone from each country. So Afghanistan, 3 people, Albania, 3 people, right? So if we want to add extra filtering, i.e., let's say that we want to find out, you know, all the countries that have at least 5 people, right? We can perform that with having. And if I escape out of that, so the way that we use the having keyword is after grouping by, we specify the having and make sure that the having keyword must be before order by. So literally right after group by. So now we can say having, and this now takes a function. So we can pass a function. So let's go ahead and say count. So count. And then, so basically we're doing the same thing. So count and then star, so every column, and then order by, so that's like that. And now we can specify the actual condition. So having count star, and then let's say that the count must be at least 5, right? If I press enter, you can see that now we get every single country where there is at least 5 or more people. So if I press Q, and then in fact let me put this smaller so you can see everything in one line. So if I put full screen and then clear that, so you can see the exact statement. Select country of birth, comma, count star, so this is the counting of this column right here, from person, group by, and then country of birth, and then having the count bigger, so this is the bigger sign, then 5, and then we can perform the actual ordering. Press enter, you can see right there. So let's go ahead and change this to a bigger number. So let's go ahead and say 40. Let's see all the countries with 40 or more people, And you can see that the list is much smaller. So Brazil, China, Indonesia, Philippines, Poland, and Russia. So we could actually also say bigger or equal to 40, right? Let's see if we find anyone. Nope. So if we say bigger than 41, so let's go ahead and say 41. So you can see that Russia will be out of the list. So Russia was here. But if I include equal, so greater or equal, you can see that Russia now is included. Now, if we put anything above 180, just China will be in this list. So if I go 180, so 180, enter, you can see that China is the only country. I can also perform the opposite. So I can say any country that has the population less than, or actually less or equal than 180. So China won't be included. So every single country is included apart from China. So you can see China is not on the list. So this is it. So basically you can use the having plus, this aggregation right here. And basically the way that you find all of these functions is if you go to the docs and search for aggregate functions, and I'm going to leave a link in the description below so you can easily access this page. And basically you can see that the aggregate functions compute a single result from a set of input values. So you can go through, there are tons of these, and you can see that the one that we used was count. So count right here, and then count with an expression. So we use count star, and basically this is the input of rows, right? So every single row. And you can use JSON aggregate, max, min. So checking, the minimum age, for example. You also have sum. And if I scroll down, you have a bunch of things. So stats, so aggregate for functions, aggregate for statistics, standard deviation, also ordered set aggregate functions, mode, and then percentile, disk, so rank. You can go through this doc and pretty much just read and see what kind of aggregation that you need for your query. Alright, in this video, let's go ahead and learn about some of the most useful aggregate functions that you will end up using. And that is sum, max, and min. So basically you've seen already count, right? You've seen count already, but I want to show you how to use the max, min, and then sum. And once you know how to use these, then to use the rest is very straightforward. And basically once you understand your data and the information that you want to retrieve out of it, then you can come to this link right here and see what functions are available. So the first thing that I want you to do is to create a brand new table using Mockaroo, and this will allow us to generate 1,000 rows into a table called car. So right here. So go ahead and add a field called ID. This will be the row number, then make for the actual make of the car, and the type is car make, and then model, and the type will be car model, and then a price. So we have a price, and this will be of type money. And finally, go ahead and give the actual table a name, so car, and also include the create table. And the format has to be SQL. Go ahead and download. And now you can see that we have car.sql. I'm going to open that up, and this will be big, and then serial, not null, and then primary key, and the rest will actually, let's increase the make and the model to 100. So this will be 100, and both not, and then null. And for the price, this will be of type numeric, and the precision will be 19 and then 2. And this should also be not and then null. And I'm going to leave a link in the description of this video so you can download this file and have the exact same data as I do. So now I'm going to go to PSQL, and basically I just want to execute that file. So if you remember, so if I do backslash and then question mark, you see that we have this option right here, which executes commands from a file. So I'm going to press Q and then backslash and then I. And if you want to know the actual path for the actual file, go ahead and pretty much just type pwd. Make sure you navigate to the actual folder downloads in my case. And then if I do an LA, you can see that I've got this car.sql. So this is what I need. So I'm going to copy this path right here and then go back, paste that / and then car.sql. Enter. And now you can see that we have a bunch of inserts. If I do select and then start from car, and you can see that now we have a bunch of cars. And one thing that I actually forgot is if you go back to Makaru, just make sure that the price is between a nice range. So in my case, I've chose between 10,000 and 100,000. It could be way bigger than that, obviously, but just for this video, let's go ahead and keep the range a bit small. Let's go ahead and find out the most expensive car that we have in this table. So to perform that, we need to use the max operation, and to use it is very straightforward. We simply type select and then the function is max. So this is the most expensive, so it's the max price. And then this takes the actual column. So what we want to pass in order for this function determine the max value. And if you have guessed, it is actually the price and then from and then car. If I press enter, you can see that the most expensive car is the one which is almost 100,000. And we could also get the actual minimum value. So instead of max, you simply say min. Just like that. And you can see that the minimum car price is 10,000. So we could also get the average of all car prices. So to get the average, you simply type AV and then G. And now the average car price in this table is about 55,000. So you see that we get these numbers right here. So 55,256 and then dot 657 and then some numbers, right? So we could actually round the actual result. So to round the average value or sum or even the minimum value, you can simply say round. So we're going to round the actual average price. So if I press enter, now you can see that the actual value is 55,257. Now we could also go ahead and pretty much group the information and see the actual minimum car price for each make. So to do that, we can simply type select and then we want to get the actual make and then model, and what we want is actually the min. So let's go ahead and get the min price and from and then car. And now we need to do a group and then by, and we have to group by the actual car and make and model columns. So if I press enter, or actually semicolon, and now you can see the minimum price for each make and model. So if I go ahead and pretty much just select the actual max price, so change that to max, enter, you can see that the max price for the same one, so Oldsmobile Silhouette, is 85. So basically this is actually the same as I can see, and that's because we only have one make for this car. So we could actually drop the model. So let's actually drop the model. So drop the model here and on the select side as well, and then press enter. Now you can see that this is a bit more different. Now you can see for Ford, so the max value is almost 100,000, and then we have Smart 11,000. And if we were to flip this, so now let's go ahead and find out the min and then press enter. And now you can see that for sure Ford has the minimum car price as 10,022.19 pences. So we can pretty much do the same for average. So let's go ahead and select the average, press enter, and this is the average for each make. So let's go ahead and actually round this. So if I press enter, you can see that now the numbers are nicely rounded. So far you've seen max, min, and average, right? So we still have to learn about the sum operator, sum right here. So sum allows us to perform really addition over our data set. So let's go ahead and sum the total price for every single car that we have in our table. So we can go ahead and simply say select and then sum and price. So price and then from and then car. If I press enter, and Postgres is complaining about these commands that I've typed, which, they're not commands really. So let's go ahead and say select again and then sum and then price from and then car. If I press enter, and you can see that the sum of all cars is about 55 million, say dollars or pounds or yens, depending on the currency that you actually use. So you can see that it's performing a sum over the entire table. Now let's go ahead and aggregate this and see the total sum by the actual car make. So go ahead and simply say select, and then let's go ahead and say car, or actually make, and then sum, the actual price, from, and then car, group by, and then the actual make. So if I now press semicolon, enter, and now you can see that the Ford make, so right here, has a total sum of 4 million. And you can see smart right here, which is just, I think, one car, so 11,000. You have Dodge, which is about 2.5 million, Maserati, so on and so forth. And this is how you use the sum aggregate function. In this video, let's go ahead and learn some of the arithmetic operators provided by Postgres. So these allows us to perform maths behind numbers, and basically we can use our data set to produce some kind of statistics or any kind of result really that you want. So for example, you want to find out the discounted price for a product given 10%, right? So you can run the query which selects that column and then perform some kind of arithmetic operation and then produces you a result. And I'm going to show you that in a second. But first, let's go ahead and learn the basics of arithmetic operators. So we can perform addition. So go ahead and simply type select, and then let's go ahead and say 10 and then plus and then 2. So if I end up semicolon, you can see that the result is 12. And right now you see that we have this column right here, so question mark column and then question mark. So don't worry about this. I'm going to show you exactly how to rename this in a second. But you can see that the result of 10 plus 2 is 12. We can also go ahead and perform subtraction. So 10 minus 2 equals 8. We can also perform multiplication. So 10 times 2 equals 20. And also you can chain these, right? So if I perform 10 plus 2 and then plus and then 8, you can see that the result is 28. We can also go ahead and perform division. Oops, sorry, if I delete that, we can perform division. So 10 divided by 2, you can see that the result is 5 right here. We can also perform the power of a number. So 10 power 2. So the way that you write power is simply by using this hat. And then 10 power 2, we all know that is 100. So 10 power 3, or actually 3, sorry. So 10 power 3, you can see that it's 1,000. So we could also perform the factorial of a number. So 10, and then the way that you perform factorial is actually if I perform select and then 5. So I want the factorial of 5, and you simply place a exclamation mark, and if I run this, you can see that the result is 120. And the final operator that I'm going to show you is the actual modular. So the modulus operator allows us to get the remainder after a division. So let's go ahead and say select, and then let's say 10, and then mod. So you simply use the percent sign, so 10 mod 3. So let's think about this for a second. So how many times does 3 goes into 10? So 3 goes into 10 3 times, and then the remainder of the result is 1. So you can see right here, 1, right? So the same, we could do the same for, let's say, the modulus of 4. So 10 modulo 4, so 4 goes into 10 2 times, the remainder is 2, and pretty much if I perform 6, so let's go ahead and say 6, or actually 5 first. So 5 goes into 10 2 times, so the remainder is 0, but 6 goes into 10 1 time, and the remainder is 4. So this is all for this video. As you can see that the arithmetic operators are very straightforward to use, and basically like any other language like Java, C#, C++, Python, PHP, they all support arithmetic operators. Let's go ahead and select every single car from the car table. So select and then star, from, and then car. So right here you can see that we have a bunch of cars, and then we also have the actual price. Now let's say that we want to run a promotional discount to every single car that we want. So let's say that we are offering 10% of the original price, and what we want to do is to have a query that returns the original price plus the actual discounted price with 15% off. So let's go ahead and press Q, and the way that we will do that is simply by saying select, and let's go ahead and select every single column by the column name. So ID, and then make, model, and then price, from, and then car. So just to see what we're doing, so it's the exact same thing. So now we can go ahead and actually perform a bit of calculation. So we want to grab the car price, so price, and then we want to times that by 0.10. So this is actually 10%. So if I press enter, you can see that we have the 10% value of each price. So for example, 87,665.38 is 8,766.53.80, and you can see the same for all the rest. Now let's go ahead and pretty much just round this to 2 numbers. So we can go ahead and use our round function. So round times the 10%, and then comma 2. So this is 2 decimal places, enter, and now you can see the actual value into decimal places. And effectively we want to know the discounted price with 10%. So to do that, we need to pretty much just do almost the same thing. So let's keep the 10%, and now I'm going to round again. So I'm going to round that result, and within parentheses, let's go ahead and grab the price, and then we're going to take away the actual 10%. So make sure you add another parenthesis, and inside simply type price, and then times point, and then 10. And if I press enter, now you can see that, and in fact we don't even need or actually let's add the 2 decimal places. So if I press enter, you can see that now this is the value after the 10% off. And in fact what we just did was the price, so the price minus this discount right here, and basically this gives us 7,898.84 for the very first car, and you can see the rest for all of those. So basically this is it, right? So this is how you use arithmetic operators with your data. Obviously you could do much more complex calculations, but I just want to give you a gist of how it looks and how you actually, grab the column that you want and then perform some arithmetic upon it. Alright, so to conclude this section, if you look carefully on what we did in the previous video, i.e. we got the 10% value, and then this was the price after the 10% of the original price. So if you look carefully on the actual table column names, so you can see that we have ID, make, model, price, and then we have round and then also round. So this is not right. So by default, if you don't specify a column name, Postgres will use the actual function name as the column name, or sometimes it will give you those question marks and then column question marks as we've seen before. So let's go ahead and actually use the alias keyword to provide a name for these columns. And in fact, you can use the alias keyword for overriding any column. So let's go ahead and press Q, and pretty much on the same SQL query. So remember, the first one was the actual 10%. So to override the name, you simply have to say as and then give it a name. So I'm going to say as and then 10 and then percent. And actually, let's go ahead and instead of price, let's go ahead and simply rename that to as and then original price. And for the discounted price, let's go ahead and rename this to, so go ahead and say as, and if I make this smaller so you can see properly, so as and then discount after 10 and then percent. So a very long column name, but you get the idea. So now if I press enter and if I make this bigger, so now you can see that we did override the original price column. So now it's called original price, and then we have 10% and then discount after 10%. And in fact, the names are not consistent, but just let me correct that. And then if I press enter, and now you can see that we have original price, 10% value, and then discount after 10%. And this is how you override the original column name. Alright, in this chapter, let's go ahead and learn how to handle nulls with Postgres. The first keyword I want to teach you is the coalesce keyword. So basically, the coalesce keyword allows us to have a default value in case the first one is not present. So go ahead and pretty much type select and then coalesce, so coa and then less. And inside of this function right here, simply type 1. And then if I press semicolon, you can see that we have the result, which is 1, right? So in fact, let me go ahead and has and then name, or actually number, right? And then press enter, and you can see that the number is 1. And when the first parameter for this function is null, it will simply give us the second value by default. So if I press enter, you can see that we still get 1. So we could also have multiple parameters. So basically, if the first value is not present, try the second one. If that one is not present, try the third one, so on and so forth. So if I press enter, you can see that we still get 1. But if I was to have, for example, 1 and then 10, you see that we still get 1 because it finds the very first value which is present in this entire array of values. And this is the coalesce. Now let's go ahead and pretty much just use this coalesce keyword with our data set. So let's go ahead and select everyone from person. And right here, you can see that we have a bunch of emails. But also we have people without email. So right here, you can see that this person called Omar doesn't have an email. Nikos doesn't have an email. Nolly, Tynan, both don't have an email. So let's say that we want to select every single email. And for those people that don't have an email, we simply want to have an email with the value of email not provided. So to do that, what we're going to do is pretty much just select just email. So select and then email from and then person, enter. You can see that we only have emails, but obviously we have people right here without emails, right? So here, here, and here. And if I scroll down, you see a lot more. So let's go ahead and now use the coalesce syntax that we've just learned. So coalesce, so coa and then less. And then within parentheses, we will have an email, right? So if I press enter, you see that nothing changes. But now, if I go ahead and pretty much just write the same command or the same query, press comma, and then right here, I can specify the default value when the email is null. So right here, I'm going to say email not provided. And then press enter. And now, if you look at this, you can see that we have email not provided here, right here, right here, right here. And if I scroll down, we should see a lot more. So right here, and that goes forever. And this is it. So coalesce is very powerful. So whenever you have a column which is null and you want to have a default value, use coalesce. In this video, let's go ahead and see how we can tackle division by zero. So if you've done any kind of programming, so OOP, languages such as Java, C++, if you try to perform a division by zero, that will blow and throw an exception. So similarly with Postgres. So if I pretty much just select and then 1, or actually let's go ahead and use a bigger number, so 10, and then divided by 0, right? So 10 divided by 0, it doesn't really make sense. And it's like me saying to you, I've got 10 apples and I want to divide it by 0 people, right? It doesn't make sense at all. And this should throw an error. So if I press enter, you can see that we have this error right here, division by 0. So how do we tackle this? Well, we have a special keyword, and that is null if. And basically, null if takes 2 arguments and returns the first argument if the second argument is not equal to the first argument. And let me go ahead and demonstrate this. So if I pretty much just type select and then null and then if, and inside of this null if function, it takes 2 arguments. So we can pass the first argument as a number. And basically, if the second argument is the same as the first argument, the result of this query will be null. Otherwise, the result will be the first argument. So if I say 10 and then 10, so right here, you can see that the result is null. If I go ahead and say 10 and any other number, so 10 and 1, the result is 10. So if I go ahead and say 10 and 19, still 10. And if I flip this around, so if I say, for example, 100 and then 19, the result should be 100 because 19 is not equal to 100, as you can see right here. And if I say 100 and also 100, you can see that the result is null. So what we can achieve with this is if I select and then 10 divided by null, you can see that Postgres doesn't throw an error. And that means that we can now safely perform our division. So select 10 and then null if, and then pass 2 and any other number. You see that we get the correct output. So 10 divided by 2 is actually 5. So this means that now if I pass 0 and 0, and this is what we actually care about really, is if there is a division by 0, we don't want to throw an exception or an error. We simply want to return null. So I can go ahead and press enter, and you can see that no error, and we can use the coalesce as you've seen before. So I can say coalesce and then select 10 divided by null if 0 0, and then I can have a default value. So let's go ahead and press 0 and then enter, and I get syntax error, and that's because I need to perform a select before coalesce and then enter, and my bad. So what I need to do is really remove this select right here. So if I press enter now, you can see that the result, so if I run that again, you can see that the result is 0 instead of null. So this is how you handle division by 0. Alright, in this video, let's go ahead and learn how to use dates with Postgres. So dates is a useful concept that you must know how to use with Postgres, because often when you store results in your tables, you want to record some kind of timestamp, i.e., for example, when the record was originally created, or when the record was updated, or for example dates, so date of birth, as we have in our table called person. So there is one function that gives us the actual date. If you type select and then now, so this is a function, and press enter, you see that this gives us the actual timestamp. So the timestamp is a combination of the date, so this is the actual date, and then hour, minute, and millisecond, or actually second plus millisecond, and also the actual time zone. So this is the actual shift of the actual time. And basically from this timestamp, you can actually gather the date if you want. So to get the date, you can cast this to a date. So simply press double column and then date, and end that with semicolon. And now you can see that I only have the actual date. You can also get the time. So instead of casting to a date, you can cast to a time. So right here, you can see that the time is this. So hour, minute, seconds, and then plus milliseconds. So this is it really. So if you know how to use these, then you should be on a very good shape. And if I go to the docs, right here, you can see that they have some documentation on date and time types. And I'm going to leave a link in the description below so you can go through this documentation. But basically, if I scroll down, you can see that you have date and time types, and right here you have timestamp, and you can have a timestamp without time zone or with time zone. So depending where you live, you can specify the actual time zone. Then you also have date and then time with time zone and without, and also you have interval. I'm going to show you guys exactly how to use interval in a second. But if I go back to PSQL and describe our table called person, so right here you can see that we already have used the date type, right? So for example, if you wanted to have a timestamp without time zone, you simply type timestamp without time zone, or actually this one here, or with time zone, simply with time zone. So if I go ahead and pretty much just select and then now, and you can see that this is my current timestamp right here. So for you will be different. But now let's say that we want to subtract 1 year from now. So to do that, we can say select and then minus, so we can subtract, and then you simply have to say interval. So this is a special keyword, and then within single quotes you can say what you want to subtract. So you can say 1 and then year. If I end that with semicolon, you can see that now we're going back to 2017. I can even go ahead and say 10 years, so 10 year or years, and you can see that I'm going back to 2008, and this was about recession, so recession time, so basically financial crisis time. But yeah, so you can also say, let's say months, so you can take away months, right? So I'm going 10 months back, so we're going back to February. You can also go ahead and say 10 and then days, right? So day or days, they both work. So I'm just taking away, but you can also add. So I can go ahead and add if I clear the screen so you can see it properly. So now plus and then interval 10 days. You can see right there. So if I go and say 10 and then months, we should go to 2019 right here. And this is useful sometimes when you want to perform addition and subtraction with dates. So I've selected now, but you can also cast this to a date. So date right there. And basically you can simply get the actual date. So what you have to bear in mind is that the whole thing, so this whole function right here, returns timestamp. So if you simply want the actual date, and you can see that right here, I've got the hour, minute, and second, you simply have to wrap everything and then cast it. So date here, and if I go back, so I can remove this casting and then cast the entire statement. If I press enter, now you can see that we're simply getting the actual date. Alright, so we've been working with date so far, and I want to show you this function that allows us to extract specific values from a date. So go ahead and say select and then now. And let's say that you simply want to extract the actual year from this timestamp. So you can go ahead and say select and then extract, and then within the parentheses you can say what you want to extract. So I want to extract the actual year, and then from, and then your timestamp. So now if I press semicolon, you can see that now we are extracting the actual year. You can go ahead and extract the actual month as well as the day, also the day of the week. So this is DAO. You can see that this is Sunday, and I think Sundays is 0 if I'm correct. And you can also extract the actual century. So century, and if I press enter, you can see that we are in the 21st century. And you can also extract like milliseconds and other things, but basically I just want to show you how to extract the essential values from a given date. Alright, let's go ahead and learn about the age function. So if I describe our table called person, you can see that we have first name, last name, gender, email, date of birth, and country of birth. So let's go ahead and perform a select, and then first name, last name, gender, country of birth, and finally date of birth, and then from person. If I press enter, or actually country or county, so it's not county, it's country, and then of birth. And if I press enter, you can see that we have our table with a bunch of people, including first name, last name, gender, country of birth, and date of birth. So now let's go ahead and have an additional column with their actual age. So if I press Q, we can go ahead and run the same command, and I'm going to press Ctrl L to clear the screen. And we can use this function called age, so age, and then the age takes 2 arguments. So the very first argument is the actual current timestamp, so or i.e. the starting date that you want to calculate the age, and then the second one is the actual date or date of birth in our case. So let's go ahead and pass date and then of birth, and then if I say as and then age and then press enter, and you can see that now we have an extra column with the actual age. And you can see that it even includes the actual month, days, and also the actual timestamp. And obviously you could go ahead and extract whatever field from this age right here, but I'll leave that up to you. Let's say that you have a table with two people, and those two people have the exact same column values for first name, last name, gender, date of birth, and email. So you can see in this table, you have two women called Anne Smith with the same date of birth and an email which is almost the same apart from the actual domain, one with Gmail and the other one with hotmail.com. Now, if you were to uniquely identify, for example, the first row, how would you do that? Well, in this table, it's impossible because there is no column that can be uniquely used to identify someone. So if you are given these two women, to distinguish between them. And this is where primary keys come into play. In real-world example, the way you identify a person, it could be, for example, by using the passport number. And that's guaranteed to be unique for everyone. There are other documents that you could use, but let's stick to passport number in this example. Now, the passport number in this case can be used for our primary key. Primary key is a value in our column which uniquely identifies a record in any table. In our case, it identifies a person. And in this course, what we are using as primary keys are numbers. So 1, 2, so on and so forth. And the way that we are managing those is with a sequence. We could use a different data type for our column ID, and I'm going to show you the best one which guarantees to be unique every time it's generated. But for now, big serial is fine. Alright, in this video, let's go ahead and understand how to work with primary keys. The first thing that I want you to do is to describe our person table. So if you remember correctly, when we created this table, so just let me show you the actual command that we used. So that was create table, person, and then ID, big serial, not null. And then you can see that we used primary key. And this tells that this column is what uniquely identifies a person in this table. So if I go back to PSQL, so right here, you can see that we have this person underscore PK, and then this is a primary key. So when we created this table, this is already given to us. So also you can see that we have this sequence right here. So this big serial type is managed by us by the actual sequence. So remember, we never manage this, and this is auto incremented by itself. So what I want to do is actually go ahead and select. So let's go ahead and select and then start from person, and then let's also add a limit of 1. If I press enter, and as you can see, we have this person with an ID of 1, and her name is Alfreda. Now let's go ahead and insert a person into this table right here with the same ID as Alfreda. So what I'm going to do is open VS Code, and I've got this insert statement. And what I'm going to do is add ID right here. And also I'm going to add 1. Now I'm going to grab this line, Command C or Control C if you are on Windows, go back and then paste that in. And now you can see that the insert statement did not work. And this is because we have already a person with an ID of 1. And you can see that the error says duplicate key value violates unique constraint person key. So basically this person key right here, so this one is this one here, it's our primary key. And we can't have someone with the same ID. Basically it's the same thing as if I was to change my passport numbers to be the same as yours. It doesn't make sense, right? Because otherwise given a passport number, you could identify two people, which that will never be the case because passport numbers are unique per person. Now, let's go ahead and actually drop this constraint, right? Because this is a constraint, and you can see that right here, violates unique constraint. So let's actually drop this and then insert the same person. So the way that you drop the primary key constraint is by altering the table and then dropping the actual constraint. So what you need to do is simply type alter table, and then the table name is person. And then what you want to do is to drop and then constraint, and then the constraint is this person key right here. So I'm going to copy that, paste that, and then end that with semicolon. If I press enter, you can see that that worked. Now if I describe the table again, if I just clear the screen first and then person, you can see that now we don't have a primary key. So if I go ahead now and try to insert that same person with the same ID as Alfreda, and in fact it's the same person but twice, press enter. Now you can see that the same command that didn't work when we had the primary key now works. Now if we go ahead and select and then start from person and then where ID equals to 1, press semicolon, you can see that now we have two female with the exact same ID, and in fact with the exact same first name, last name, pretty much everything is the same, right? Now, if we want to identify these two people, basically it's impossible for us to do so because they have the same ID. Now you do understand the importance of having an ID as the primary key. So basically IDs allows us to have a unique value that identifies a record in a given table. In the previous video, we dropped the primary key constraint and then we added two people with the exact same ID. So you can see right here, if you perform a select where the ID is equal to 1, then you should get two people back. So Alfreda right here and also right here. So now let's go ahead and try to add the primary key back and see what happens. So to add a primary key, we simply have to alter the table. So alter table, and the actual table is person. And remember, when we dropped the constraint or the primary key constraint, we simply said drop and then constraint and then the actual constraint name. Now to add a primary key, we can simply say add and then primary key. And now the primary key receives an array of values. And this is because you can compose a primary key based on multiple columns. In our case, we only need the ID to be the primary key, and that's absolutely sufficient. But there are times where one column is not sufficient. In that case, you can pass multiple values inside of this parenthesis. But for us, we want to add back our primary key, which was the ID. So let's go ahead and pass ID. And before I press enter, I want you to have a guess whether this command will work. So we want to add a unique constraint on the column ID. So we want the ID to be unique for every single row. So if you have guessed it correctly, then the answer is no. And this is because we cannot add a primary key when the rows are not unique in our table. And this is true, right? So you can see right here that if I pretty much just select, so you can see right here, you can see that we have two people with the same ID, right? So this doesn't work. Now the way to fix this is to actually delete. So we have to delete these two people, right? So the way that we delete a record from our table, and I know that we haven't learned this, but I'm going to cover this in a later chapter. we have to simply say delete and then from and then the actual table name, so person, and then we have to use the where clause because otherwise we will delete every single person in this table, which we don't want, and then ID equals to 1. If I press semicolon, you can see that the delete returned 2 rows, so you can see right here, and this is because we had 2 people with the same ID. Now if I go ahead and try to select, so select where the ID is equal to 1, you see that we have 0 rows. Now we are absolutely sure that the ID column is unique in our table called person. And in fact, let's go ahead and add the actual person with ID of 1. So let's go ahead and add. Now if I clear the screen and then select start from person where ID equals to 1, we should only have 1 person. So now what we can do is add the actual primary key constraint. So let's go ahead and say alter and then table person add primary key, and then the actual column name will be ID. If I press enter, you can see that this time it works because the IDs were uniquely in this table. So now we can go ahead and pretty much describe the table and then person, enter, and now you can see that we have our primary key back. So remember, if you want to add a primary key, you have to make sure that the column that you want to be the primary key is unique in every single row. In this video, let's go ahead and learn about the unique constraint. The unique constraint allows us to have unique values for a given column. So what I want to do first is give you the reason why we have to use unique constraint, and then I'm going to show you how to actually apply the constraint. So let's go ahead and select and then pretty much just say email, and then let's count star from and then person. Now let's go ahead and group by and then email, and then if I press enter, you can see that we do get the actual email plus the count. So this is actually grouping by the actual email, and right here you can see that we have 292 emails which are null. So now I'm actually interested to see whether we have duplicate emails. So I'm going to say having and then count and then star bigger than 1, right? So if I press enter, and as you can see, we got 292 emails which are null. So now what I want to do actually is if I open up VS Code and let's grab this insert right here, and instead of Alfredo, let's go ahead and change the name to Fernanda, and then grab this Command C and then go back to PSQL, paste that, and you can see that the insert did work. So now let's go ahead and run the same command. So we're going to group by the actual email, having count bigger than 1. Press enter, and now you can see that we have a duplicate email, right? And in fact, if I go ahead and pretty much perform a select, so select and then start from person where and then email equals to, and then paste that in, semicolon, and you can see that right here we have 2 females. So we have Alfreda and we also have Fernanda. Now let's say that we want to send an email to Alfreda, so this Alfreda right here. So we would have a problem, right? Because both Fernanda and Alfreda have the same email. So we don't know exactly to which person the actual email belongs. And this is when the unique constraint comes into play. So unique constraint allows us to have a unique value per column. And it's not the same as the primary key, because primary keys are used to identify a unique row in a table, and having a unique constraint, it simply means that you can only have unique values per column. So this column right here called email should only have unique values, i.e. we should never get into the scenario where we have two people with the same email. So to add the actual constraint is very simple. So if I clear the screen, and let's go ahead and try to add the constraint first. So to add a constraint, you simply have to alter the actual table. So table and then person, and then we can say add and then constraint, and we have to give it a name. So let's go ahead and say unique and then email address, and then simply say unique. So this is the actual keyword. Now inside of parentheses, you could actually pass multiple columns to be unique, and this allows you to have a set of values which are unique per table. But in our case, we simply want the email to be unique. So if we go ahead and try to add the email, so email and then semicolon, if I press enter, you can see that we get an error, and it says that could not create unique index, unique email address. So this is the actual name that we have given it. And the reason why it can't create is because it found that this email right here is duplicated. And in fact, if you remember correctly, if I go ahead and select everyone with that email, you can see that we have two people with the same email. And to fix this, we could actually do two things. One, we can pretty much just get rid of this person right here, so Fernanda right here, or we could actually change the actual email, so this email right here, to something else, or even make it nullable. But I'm going to show you exactly how to perform delete updates properly in the next chapter. But for now, let's go ahead and simply delete this person right here called Fernanda. So to delete, simply type delete and then from person, and then simply say where ID equals 2, and then Fernanda's unique identifier is this one right here, which is 1004. So 1004, and then semicolon, and that was deleted. Now if I go ahead and try and select everyone with that same email, we should only get Alfreda. Now let's go ahead and press up a couple of times. So we want to add the actual index, so right here. So now we can go ahead and add the actual index. So alter table person, add constraint, and then the actual name, and then unique right here. So this is the keyword. And then we're simply saying that we want the email to be unique. If I press enter, you can see that that now works. And now if I go ahead and clear the screen first and then press \D and then person, you can see that we have this unique constraint right here that we've just created. And the name is unique email address. Now, let's go ahead and try to add the same person that we did, so Fernanda, with that same email. So let's go ahead and press up a couple of times and see if we can find Fernanda. So I think this was Fernanda. Yeah, so this is Fernanda. If I press enter, you can see that the actual insert now fails, which means that our table is behaving well according to the given constraint that we've just given it. And finally, let me go ahead and drop this constraint right here that we've just created. And I want to show you a different way of creating this. So let's go ahead and say alter and then table and then the actual table name. So this is person, and then drop and then constraint and then the actual name. So unique email address, semicolon, enter. You can see that that's gone. If I press \D and then person, you can see that the actual constraint is gone. Now, the other way of adding a constraint is simply by saying alter and then table and then person and then add, and you can simply say unique and then pass the actual column name, so email. Now, the difference between this way and the previous way is that now we let the constraint name be defined by Postgres. If I press enter, you can see that works. Now, if I press \D and then person, enter, you can see that we have this constraint called person email and then key. And then it's a unique constraint on email. If you have any questions on using unique constraints, drop me a message. But as I said, unique constraints allows us to have a unique value per column. It's not the same as the primary key, because primary key's job is to identify a record in a table. In this video, let's go ahead and learn about the check constraint. The check constraint allows us to add a constraint based on a Boolean condition. So the easiest way for me to explain this is if you go ahead and select everyone from this table right here called person, and you can see that we have a bunch of people, and we have this column right here called gender, and currently we have male and female. So we could technically allow other genders here. We could technically have different genders here, but let's say that we want to keep only females and males in this table right here, right? So if I open up VS Code, and let's actually grab Fernanda right here. So we have Fernanda, and for the actual gender column, so let's actually change that to hello, right? So if I grab this, so if I press Command C and then go back to PSQL and press Q and then paste that, and it fails because we have a unique constraint on email. So we've just added this in the previous video, which is fine. So let me go back to VS Code and actually change the email. So hello, and then let's grab the same row, go back to PSQL, paste that, and now that works. So now let's go ahead and select and then say unique and then gender from and then person. If I press enter, and it's not unique, it's actually distinct. So select and then distinct and then gender from person. Enter, and you can see that in this table right here, we have three types of gender. So we have male, and then hello, and then female. So this really doesn't make sense. So what the actual check constraint allows us to do is to make sure that we can only add a string which matches either male or female. And to add the actual constraint is very simple. So we have to alter and then table person, add constraint, and then we have to give it a name. So gender and then constraint. And then the actual keyword that we have to use is this one, check. So now inside of this check constraint, we pass a actual condition. And the condition that we want is that the gender column equals to female, or gender equals, and it should be just one equal, not double equals, sorry. So equals to, and then right here, male. So if I press semicolon and then try to run this constraint, you see that this fails. And it fails because we have one row which is violating this constraint, and is this one right here. So there is a person with a gender of type hello. So let's go ahead and delete this person. So simply say delete from and then person, where and then gender equals to hello. You can see that that was deleted. Now if I press up 2 times and then try to add the same constraint, you can see that now this time it works. So just let me go ahead and clear the screen and then press backslash and then D person. And now you can see that we have this check constraints, and you can see our gender constraint. So check that the gender is equal to female or the gender is equal to male. Now let's go ahead and try and add the same person with the gender hello. So if I go back and then grab this line right here, so you can see that hello is the gender, and then paste that in, you can see that that fails. So you have an error, new row for relation person violates check constraint. Now let's go ahead and change this to something else. So lol, and then grab that, go back, paste that in, and you see that that doesn't work. So now our table is enforcing the right constraint, which is to only have either male or female in the gender column. So check constraints are really powerful, and basically you can pretty much just have any condition that you want, right, instead of the check function right here. So for example, for a product, you could say that a product should have a value amount bigger than 0. So that could be one constraint. And there are many constraints depending on your data set. In this video, let's go ahead and learn how to delete from our table. In the previous videos, you've seen the importance of primary keys. Primary keys allows us to uniquely identify a record in a table. And when you want to delete a record from a table, you should always, or in most cases, use the primary key in the where clause. So you could delete by the actual primary key, but you could also delete by gender or by email or by country of birth, pretty much by anything. But you just have to be careful because, for example, if I was to delete where the gender is male, then we would only be left with female in this table. So let's go ahead first and actually delete Omar. So Omar has an ID of 2. So you've seen how to delete before, but I didn't actually explain exactly how it works. So to delete from a table, you simply type delete and then from, and then you pass the actual table, so person. So if I was about to actually execute this script, so let's go ahead and run it so that you see what is going to happen. If I press enter, you can see that we've deleted every single one from our table called person. If I go ahead and select star from and then person, you see that no one is there. So let me go ahead and open up a new shell and navigate to a folder where I've stored the SQL file. So change directory, so cd to downloads, and then if I perform an LA, you can see that we have this person.sql. So I need to know the actual directory, so pwd, grab that, and then go back to psql. So you've seen how to do this before. So \i, so for executing from a file, and then paste the actual directory, and then person.sql. If I press enter, you can see that we have the data back. And now if I select everyone, so select star from and then person, you see that we have everyone back. So you can see Omar right here. And one thing that you should notice is that the actual ID now has changed. So it's no longer 1 because we did not reset the sequence which is managing this ID. But I'm going to show you how to do that later on. So now let's go ahead and delete Omar. So if I type delete from and then person, now I'm not going to run this because you saw that it deletes everyone from this table. We can go ahead and simply say where. So this is the actual filtering. So we can say where and then ID equals 2 and then that, so 1011, enter, and you can see that now we've deleted one record. If I select everyone, you can see that Omar is no longer from this table. So you could actually go ahead and extend the AND condition. So for example, you could say, let's delete everyone from person where the gender, so gender equals to and then female, and you could say and then country of birth equals to England, for example, right? So if I press enter, so it should be country and not county, and then press enter. So we haven't got no one from England, that's odd, but let's go ahead and simply change this to Nigeria. Enter, and you can see that we deleted 3 females from Nigeria. And if I was to go ahead and select star from person, where gender, actually this entire where clause, just let me copy that instead of typing. So Command C, paste that in, semicolon. You can see that we haven't got no one. But if I change the gender to male, press enter, you can see that we have few guys from Nigeria. Now let's go ahead and delete all the females from this table. So delete from person, where, and then gender equals, or actually let's delete the guys. So male. So if I press semicolon, you can see that we deleted more than half of our data. So 516 guys were gone. So if I select everyone, so select start from and then person, you should see that we only have female from this table. So as you see, like delete is very straightforward. So you can use the where clause to filter to a specific row or multiple rows with the AND condition. So bear in mind that using the delete on its own, as we did, so just saying delete from person, it's very, very risky. Again, you never want to do this in a production database, because otherwise you just wipe out the entire table and then you can get into trouble. So it's always best to use with the actual where clause and then delete one person or one record from your table, or few records from your table, depending on your where clause. This is all for now. If you have any questions on using the delete keyword, drop me a message. But in the meantime, what I'm going to do, so let's go ahead and just simply cancel that. So I'm going to delete everyone because, so just let me cancel that. So delete from and then person, because I want to add everyone back into this table. So we deleted the remaining females, and now I simply have to find the command where I execute from the file. So this one right here, enter. And now if I do a select start from person, you can see that we have everyone back into this table. Alright, in this video, let's go ahead and learn about the update command. The update command allows us to update a column or multiple columns based on our where clause. And also you could update every single row if you don't provide a where clause. But usually providing the where clause is more sensible because you have control of what you're actually updating. So let's say that we want to update this person right here, so Omar. So we want to update his email from null to an actual email. So the way that we do that is as follows. So we have to use the update command, and then we have to specify the actual table. And now we have to say set. So this set allows us to pass an array of columns, including the new values. So right here, we could say email equals to, and then this would be the actual new value. So I could say Omar and then at gmail.com. If I was about to press semicolon and then execute this command, this would behave the same way that I've showed you with the delete command. So this would actually update every single row in our column with this email, which we technically don't want. So it's always best to use the where clause. So I'm going to say where, and right here you can pass your condition, and my condition is where the ID, so the row identifier, equals to 2011. If I press enter, you can see that we have one row which was updated. Now if I do a select and then start from and then person, where, and then ID equals 2011, semicolon, and you can see that now we did update the actual email. So let me update one more time so you can see what we're doing. So let's say that this time is Hotmail. So Hotmail, enter, and you can see that this now was updated from Gmail to Hotmail. So we could also update multiple columns. Now let's go ahead and simply update his first name and last name. So we could go ahead and say update and then person, set, and then this is the actual array of columns. So now we could say first name equals to, and then let's simply say Omar with one M. And then if you want to update a second or third or more columns, you simply add a comma followed by the next column. So right here, let's go ahead and say last and then name equals to, and then let's simply say Montana. So Omar Montana, and you could also update the email. So let's go ahead and add a comma and then email equals to, and then Omar dot Montana at, and then hotmail.com. And remember, so if we don't provide a where clause, we will update every single row with these updates, which in theory it wouldn't work for the email because we already have a unique constraint, but this is so that you know. So now I'm going to say where, and then ID equals to 2011. If I press enter, you can see that worked. Now I'm going to select Omar again, and you can see that now we have updated his first name, last name, as well as the actual email. And this is how you use the update command with Postgres. Just bear in mind that whenever you perform an update, delete, you always want to have a where clause, because otherwise you might update or modify your entire table. Alright, in this video, let's go ahead and learn how to deal with duplicate key errors or exceptions. So let's go ahead and select Omar again. So select start from and then person. So actually let's go ahead and pick someone else. So let's go ahead and pick this person right here. So Russ. So 2017, that's the actual ID. So, and then where ID equals to 2017, right? So remember, the ID column, so this ID column right here, is the value that uniquely identifies Russ in this table. So this guy right here called Russ. So meaning that if you were to insert someone with the exact same ID, your query should never work and throw an exception or an error saying that the key is already in use. So let's go ahead and try. Let's go ahead and simply say insert and then into and then person. Right here, let's go ahead and add the actual ID, first name, last name, gender, email, date of birth, and finally country of and then birth. And then don't press semicolon and press enter. So we're going to continue on a new line. And now we're going to say values. And then within parentheses, let's go ahead and try to add someone with the exact same ID as Russ. So 2017. And let's go ahead and pretty much just try and give it the same name. So Russ, and then they should be in quotes, and then last name. I'm not even sure if this is a real name. So, and then male, and then the actual email, just let me grab it. And then the actual date of birth. So remember, date, and then first comes the actual year, or 1952, September, and then the 25th. And the country is Norway. Now, if I press semicolon, and I want you to have a guess whether this will work. So remember, I said that the actual ID is the unique identifier for this column. So we're trying to add a second person with the exact same information as Russ, including the actual ID. And in fact, you can see that the error says duplicate value violates unique constraint. And the constraint is the person primary key. And you can see in the actual detail, it says key ID 2017 already exists. So there are times where you don't want to blow with errors or exceptions, right? So Basically, you want to handle the case where you have conflicts. And this is when you use the onConflict keyword. So let's go ahead and pretty much just press up one time. And instead of running the same command again, remove the semicolon and then press enter. And now we can say onConflict. So this is the actual keyword that allows us to handle onConflict scenarios. So onConflict, and then we have to pass the actual column that might be in conflict, and in our case will be the ID. And then we can say pretty much do and then nothing. So if I press semicolon, now if I run this, you can see that we have no errors, and right here you see that no inserts were performed, so 0, 0. And this is how you handle duplicate key errors. Now we catered for the actual ID, so ID right here, but we could also have a conflict for the actual email because our email has a unique constraint. So if I press \D and then person, you can see that right here we have a person email key and then the unique constraint, right? So if I go ahead and clear the screen, and then instead of actually saying onConflict ID, I can pretty much say email, right? Do nothing, enter, and you can see that also works. But this will not work if you don't have a unique column, right? So if I was to pretty much just pass first name here, so first and name, enter, you can see that there is no unique or exclusion constraint matching on the onConflict specification. So whenever you want to use the onConflict, make sure that your column is unique, i.e. have a constraint, either a primary key or a unique constraint. And you can also have an onConflict on multiple columns if you wish. In the last video, you saw how to use the onConflict do nothing, and you saw that if you have a conflict on a unique column, that means that your query has no effect. But sometimes you pretty much want to do something else other than do nothing. And a good example is, let's say that, for example, you have a user registering on your website, and then he performs a request to register to your server, right? So he performs a request to add his details to your server. Now, it could be the case that the user submits his information, but then immediately changes his mind and then updates his email with the exact same detail, right? So in the first request, he sent one email, and then in the next request, he sent a different email, right? So in this case, basically, sometimes you might not use the do nothing keyword, but instead you want to take the latest insert that comes from your client. So this usually happens when you work in a distributed system where you have two servers sitting above a load balancer. So just let me show you how this works. So if I press up a couple of times, so I pretty much just want to select this person right here, so Russ. And if I go ahead and perform this request, you see that there is no insert, so 0, 0. Now, if I go ahead and select it again, you see that no information changed. So let's say that this was the actual first request that they added. So they wanted to register with this information. And then about 2 seconds later, he decided to add a .gov.uk at the end of his email, right? So he sent the exact same information, but .uk at the end of his previous email. So this is where you use the onConflict, so onConflict, and instead of saying do nothing, you can say do and then update. And the do update works pretty much the way that you saw how to use the update command. So we have to say set, but now this is where the magic happens. So you're going to say email, so you want to take the email, so the current email which is stored in the database, and then you want to say that this is equal to excluded, so this is a special keyword, and then dot and then email. So basically this email right here, so this email relates to this one right here, right? This one right here. And then the excluded dot email refers to this one right here, the one which is about to be inserted. So if I press semicolon and then press enter, you see that this time we did affect one row. So if I select Russ again, nothing changes because the email was the exact same thing. Now let me just clear the screen, select him again, and let's run the exact same command, but this time let's change the email. So I'm going to add a .uk at the end. There we go. And then press enter. You see that works. Now if I select, you see that now we had a conflict, but we simply changed his email. So this excluded dot email was the one about to be updated. And pretty much I've simply used email, but you could also add a column, and then let's say that you want to update pretty much every single value. So if I go back, and then right here you could say set, and then if I press enter, so we could say email, and you could also say, let's say last and then name equals to, and then excluded dot and then last name. And you can pretty much do for the rest. So the order doesn't really matter. So first name equals to excluded dot and then first name, and you get the idea. So if I press semicolon, run that, you see that that works. Now if I was about to change the name to Russell, and then the actual surname to Rudy, press enter, you see that works. And if I select Russell now, right, you can see that only the actual first name and last name were changed. But if you look at the email kept the same. And this is how you use the on conflict do update. So this allows you to perform an update or insert, hence the name upsert, and pretty much allows you to override existing data if present, otherwise insert a new row. Alright, in this video, let's go ahead and learn about foreign key joins and relationships. So far we have two tables, person and car. And what we want to be able to do is to have a query that returns a combination of both person and car details for a single person. I.e., we want to have a select query where we select the person as well as the car. Now, the naive approach for this would be to have a table called person, and then we could stick every single information inside of person table. So right here you can see that you have the person details as well as the car information. And for example, if you wanted to store the actual address for that person, you would stick more data into this table. Now this is bad because we are learning about Postgres, and Postgres is a relational database, i.e. you could have multiple tables and then connect them together based on a foreign key. So, and also right here in this table, you can see that we have a bunch of not nulls, which means that if you were to insert a new record into this table, you'd also have to insert the actual car information. And remember, not everyone has a car, so this is a very bad approach. So essentially what we want to represent is that a person has a car, a person can only have one car, and finally a car can belong to only one person. So to achieve that, what we can do is actually have a relationship. And a relationship looks like this. So right here in this table called person, you can see that we have a new column called car underscore ID. And this is the actual foreign key. So this is what a foreign key is. So a foreign key is a column that references a primary key in another table. So you can see that this foreign key links to the actual primary key inside of our car table. And in order for this to work, the types have to be the same. So you can see that this is a big int. So the foreign key is a big int, as well as the actual primary key inside of the actual car table. And the syntax goes like this. So car underscore ID, the type, and then you say that it references, so references and then the actual table, car, and then you have to specify the actual column that it references. So right here, you see that we pass the ID, and the ID is this column right here inside of car. And then I'm also saying that the actual foreign key is unique. And this makes sure that a car can belong to only one person. And also we are saying that a person may or may not have a car. And finally, that a person can only have one car. Alright, in this video, let's go ahead and add a relationship between our two tables. The person called car as well as person. So the idea is that one person can only have one car, and one car can only belong to one person. So if I describe our tables in our database called test, you can see that we have two tables, car and person. So what we're going to do in this video is drop these two tables because I want to remove the entire data in it, as well as create the actual tables from scratch. Now let's go ahead and drop and then table. So you've seen this before, person, and let's also drop the car table. So just like that. And now if I press \D and then T, you can see that no relations found. Now go ahead and download this file right here, which you can find in the resources link, and it's called person- and then car.sql. So this will be our file that we're going to edit and add the relationship between person and car. So right now it's just what you've seen before, right? So this was the person table and this is the actual car table. And what we want to get out from this is that a person can have one car and a car can only belong to one person. So to do that, we need to add a new column. So this column will serve as the referencing column to the car table, i.e. the foreign key. So to do that, let's go ahead and simply say car and then underscore ID. Now I need to specify the actual data type. So I can't simply just go ahead and say big serial, because big serial is a special data type which is managed by a sequence. And instead what I need to use is big and then int. So they are pretty much the same in terms of the actual size, but the difference is that big serial is a special type which is managed by a sequence. Now we could also go ahead and say not and then no, but the reason why we're not doing this in this column is because a person may not have a car, right? Not every single person has a car until they become 18 or 16 in some cases. So I'm going to remove that. And now to add the foreign key or the relationship between person and car, I need to add references, and then I need to specify the actual table. And now I need to specify to which column this car ID will reference. So in our case, so simply within parentheses, simply say ID. So this ID right here is this one right here, and this ID is our foreign key. Now remember, I also said that a car can only be owned by one person, which means that we can add a unique constraint. And the way that you add unique constraints within your table creation is simply by saying unique and then pass the actual column. So car underscore ID. And this is all. So now go ahead and save this. And now what we need to do is to execute these two table creations plus the inserts. Now, if I was about to pretty much just insert this table first, this would fail. And that's because this car table doesn't exist. So just let me show you. If I grab that and then go back to item, paste that, and you can see that right here, relation car does not exist. So I'm going to clear the screen and then go back to VS Code. And what I'm going to do first is create this table called car. And I'm just going to put it first right here and make sure you have this exact same setup. So just like that. And then save this. You could go ahead and pretty much just copy and paste all of that. But what I'm going to do is execute from a file. So \I, and then the destination is users / amigos code, and then / downloads / and then person dash and then car.sql. Now I'm going to press enter, and you can see that no errors, and we have 3 people and 2 cars. So let's go ahead and check. So select and then start from car. You can see that we have 2 cars, and let's go ahead and select start from and then person. And you can see that we have 3 people. And right here, you see that we have this new column called car ID, which we haven't assigned to anybody. All right, in this video, let's go ahead and assign 2 cars to 2 people. So right here, you can see that the car ID column in person is completely empty for every single one. So what we're going to do is simply update this value with these 2 cars. And you will see that the constraint that we added, so this one right here, \d and then person. So this one right here, so unique and then car ID, is actually working. And in fact, we forgot to add the uniqueness constraint on the actual email, but you've saw that in the previous video. So let me go ahead and delete that and select from person first and then from car. Now let's go ahead and assign a car to Fernanda. So let's go ahead and say update and then person and then set and then car ID equals to, and let's pick this one right here. So Land Rover equals to 1, where and then ID equals to 1. So actually, just let me change this so it's not that confusing. So basically what I'm saying is I'm going to set the car ID. So let's actually change this. So 2 and then 1. So 1 is Fernanda. So we're going to change Fernanda's car ID column. So Fernanda ID is 1. So this is 1 right here. And we're going to assign her this car right here called GMC. So the car ID is actually 2. So this 2 right here corresponds to this one. So if I go ahead and press enter, you can see that works. Now if I select everyone from car, or actually person, you see that Fernanda right here has a car. So you can see right here. So let's also add a car to Omar. So update person, set car ID. And for now, let's actually try and add the same car so you see that our constraint is working. So where the ID of Omar is 2. So I'm going to press enter, and you can see that. So if I clear the screen and run the same command again, you can see that our unique constraint is working. So car ID is already taken. So let's go ahead and select start from person and from car, so you can see properly. So now what we're going to do is give it this car right here, so the Land Rover. I'm going to press enter, and now if I select everyone from person, select start from person, you can see that we have Omar right here with car ID 1. And in fact, let me select all cars and then car from and then car. You can see that Omar has the car ID of 1, so you can see that it's a Land Rover. And then Fernanda right here has car ID 2, so which is this one right here, GMC. And this is how you set a value that corresponds to a key in another table. And if I was about to actually update a person, so let's try now. Adriana. So Adriana has an ID of 1, but now let's try and add an ID that doesn't exist. So 4, right? Or even 3, right? Because there is no ID 3 in this table. So if I was about to run this, and in fact, let me run it, you see that insert or update on table person violates foreign key constraint. And it says that car ID 3 is not present in table car, which is true. And that's the power of foreign keys. It means that you can only assign a foreign key when there is a relation in the other table. Alright, now that we have a foreign key constraint between our two tables, person and car, let's go ahead and learn about inner joins. So inner joins is an effective way of actually combining two tables. And the way it works is that you have a table A as well as a table B. And what you want to do is actually combine these two tables. Now, the inner join takes whatever is common in both tables. So if you have a record inside of the table A and also a record inside of the table B, so if you have a foreign key which is present in both tables, then it takes those two records and then gives you the result of both, which we're going to call it C. So A plus B equals to C. And to recap, an inner join takes two tables, A and B, and then if we have a foreign key that is present in both tables, then we have a new record called C. Let's go ahead and learn how to use inner joins with Postgres. Alright, now that you know what a join is, let's go ahead in this video perform a join between our two tables, car and person. So I'm going to select star from person and also select and then star from and then car. So we want to perform a join based on this foreign key right here. So car ID links to this ID inside of this car table. So to perform a join, we simply have to say select and then star. So we want to select every single column and then from, and then here is where you specify the first table, so person, and then don't press semicolon, and then on a new line simply say join. So this is how you join to another table. Now you specify the actual table that you want to join. In our case is car, and then you need to say on. So on takes a column which can be used to join these two tables. So in our example is the foreign key. So car ID found in person will join to ID found in car. So let's go ahead and say person dot and then car underscore ID equals to and then car dot and then ID. If you go ahead and press semicolon, press enter, you can see that we've got two results. And in fact, because you can't see properly, I'm going to show you a nice trick. So if you press Q and then press backslash and then X and then enter, you can see that we have expanded display on. Now if I perform the same select, you can see that now we have this information that can be easily read. And there we go. You can see that we performed a join between two tables, and pretty much this right here is, or actually, sorry, this entire selection is everything from person, and then the rest is from car. And you can see the same for Fernanda. So Fernanda right here, she has the car ID of 2, and you can see that this is the actual car. And this is how you perform joins. So obviously, so if I scroll up, so obviously Adriana is not included because she doesn't have a car. So remember, a join simply links two tables where the primary key and the foreign key is found in both tables. So just let me go ahead and show you one more thing. So you saw that we selected everything. So select star from person. So what we can do, just let me remove that. So So you can see that we get every single column. So now what we can do is just grab certain columns from each table. So to do that, let's go ahead and say select. And now I can go ahead and say person dot and then first name and then comma. Let's go ahead and select the car dot and then make comma car dot and then model and then car dot and then price. And then we can go ahead on a new line. So if I clear the screen, on a new line from and then person, and then we're going to join. So let's join and then car on and then person dot car underscore ID equals to car dot ID semicolon. If I press enter, you can see that now we selected only the columns that we wanted. And let me go ahead and remove this expanded display on, and to turn it off, \X, it's a toggle. Now if I perform the same selection, you can see that if I remove that, you can see that now we simply selected few columns from each table. And this is how you perform a join. Let's go ahead and learn about left joins. Left joins allows us to combine two tables like inner joins, so table A and table B. And the difference here is that a left join includes all the rows from the left table, i.e. table A, as well as the records from table B that have a corresponding relationship, and also the ones that don't have a corresponding relationship, i.e. it returns all the records even if there isn't a match. And then you get result C. Let me go ahead and show you exactly how this works. So if I go ahead and pretty much select start from person and then join, so let's go ahead and first join car on person.carID equals to car.id. If I press enter, and in fact, just let me go ahead and make this smaller so you can see everything in one line. So just like that. And then if I run the same thing, so just let me clear the screen and then run that. So now you can see that we only have two people, right? Two people. And that's because if I select start from person, you see that Adriana, she doesn't have a car. So a join simply takes this condition right here and finds every single row where the ID is equal to the actual foreign key, and anything else is discarded. But now let's say that we also want to include people that don't have a car, i.e. we want to have this exact same query including Adriana. And this is where left join comes into play. So if I go ahead and select and then star from person, and then I'm going to say left and then join, and basically now everything is the same. So we want to left join to car and then on and then car dot ID equals to person dot and then car underscore ID. If I press semicolon and now press enter, and this includes everyone that has a car. So you can see Omar and Fernanda, they both have a car. And you can see that ID, make and model and also price are filled with values for both Omar and Fernanda. So you can see right here. So value 1 and then value 2. But because we performed a left join, meaning that we also wanted people without a car, you can see that these values for Adriana are null. And this is what a left join is. It basically means that you want to join both tables, including records which don't have a foreign key relationship. So now with this, we can actually find out people that don't have a car. right? We could technically write something like this. So select and then star from and then person. And then you could say where ID is null. Or actually not ID, sorry, car ID, sorry. And you can see that we have Adriana. But also with a left join. So if I clear the screen, you could also do the same as this. So you could say select star from person, left join, and then you can say where, and then car dot and then star. So star means every single column, and then is null. So if I go ahead and press enter, you can see that now we include the actual join of both tables, but only persons that don't have a car. In our case, only Adriana doesn't have a car. So let me go ahead and select the initial join. So just like that, so you can see what we're doing. And there we go. So this is giving us everyone, including those who don't have a relationship constraint. And also, let's go ahead and perform the actual join so you can see the difference. So enter. So you can see the join only gives us the ones which have a foreign key constraint in both tables. The left join gives us those who have a foreign key and also those who don't. And basically, this very first query is simply finding out those who don't have a foreign key constraint. So this is it for left joins. It's very powerful. In this example, we simply have two tables, but you could expect to perform joins on, multiple tables. And this is how you perform left join. Alright, in this video, let's go ahead and learn how to delete when you have a foreign key constraint. So let me go ahead and first add this car right here. So Mazda with ID 13. So I'm going to copy that and then go back to item, paste that. You can see that we have a car, and let's also go ahead and add a person. So let me go back to VS Code and then open a person.sql. And now let me go ahead and pretty much just grab this line right here. And what I'm going to do is actually format this a little bit. So instead of Omar, let's simply say John, and then Smith, and then Mel, and then the ID. Let's actually give an ID. So ID, and then this will be, for example, 9,000, right? And the email, so no email. So I'm going to grab that and then go back to item, paste that, and you can see that we inserted John. So if I go ahead and select start from and then person where ID equals to 9,000, you can see that we have John, and select start from car where and then ID equals to, and the ID was 13, so 13, and you can see that we have both a person and a car, and you can see that John doesn't have a car, so right here it's no. So let's go ahead and assign this car right here to John. So let's go ahead and simply say update and then person and then set car underscore ID equals 2, and this will be 13. So 13 is this one right here, is this ID for this car, and I'm going to say where and then ID equals to 9,000. So this is John's ID. Enter. You can see that worked. So if I select John again, and in fact, just let me clear the screen. So select John and also select the actual car. So now you can see that John has a car. Now, if I go ahead and delete this car right here, this will not work. And in the meantime, try and guess what's going to happen. So delete and then from car and then where ID equals to 13. If I press enter, and it should be where, or actually car, I should have car here and then where. So if I execute this command, you can see that this didn't work. And the reason why it doesn't work is because we have still one person called John, which has a foreign key to this car right here with an ID of 13. And the error is update or delete table car violates foreign key constraint on table person. And you can see the detail right here says that ID 13 is still referenced from table person. So this is what I've just said. So basically we're trying to delete this car right here, but it is still being referenced by this person called John. So remember, whenever you try to delete individual records, make sure that if there is a foreign key constraint, you need to pretty much remove the foreign key constraint before you perform the actual deletion. i.e., if I want to delete this car right here, I first need to remove the car ID from John, and then I can go ahead and safely delete this car right here. So we have two options. One is to actually delete John because there is no foreign key constraint between John and some other table, so we can delete, or we can update the car ID to null and then delete the actual car. So let's go ahead and pretty much delete John. So we're going to delete John. So go ahead and delete from person. Again, if you want, you can update this value to null, and that would still remove the foreign key constraint. So delete from person where and then ID equals to 9000. Enter. You can see that that worked. So if I select and then start from person where ID equals to 9000, you can see that we have 0 rows back. Now I can go ahead and delete the actual car. So delete from car where ID equals to 13. Enter, and you can see that the car was deleted. Select from car where ID equals 13, and you can see that the car was deleted. So a very important topic that you should be aware of, and basically you could have a cascade on your table creation, and cascade simply ignores the actual foreign key and goes ahead and removes every single row where that key is referenced. And the reason why I'm not teaching you cascade is because it's bad practice. You always want to have full control of your data and know exactly what to delete, because deleting data without knowing what you're doing can be very costly. Alright, in this video, let's go ahead and learn how to generate a CSV with Postgres. So what we want to do is actually select our data, so perform a selection, and then export that to a CSV file. So let's go ahead and pretty much select star, and then from person, let's go ahead and perform a join, or actually left join, because we want to include everyone with and without the foreign key constraint. And then I'm gonna left join car on, and then car dot ID equals to person dot car underscore ID. Press enter. You can see that we have 3 rows. Now to export this to a CSV, first I want to show you the actual help. So backslash and then question mark. And right here in this section, input output, you can see that we have this backslash copy command, which simply performs a SQL copy with data stream to the client host. And to use it, let's simply say backslash and then copy. And then within parentheses, we have to specify what we want to copy. And we want to copy these 3 rows right here. So for that, we need to perform the same query. So select and then start from person, left and then join, car on car.id equals to person underscore, or actually person dot, and then car underscore ID, just like that. And now I want to copy the entire query to, so simply type to, and then the destination of where you want to save the output in your file system. So in my case will be / and then users / amigos code / and then desktop. And then we can use a delimiter, and then within quotes this will be comma, and now we want this to be as CSV, and we also want to include the actual headers. And there we go. So if I press semicolon and then enter, and users amigos code desktop is a directory, and that's true. So basically we simply have to give it a file name. So let's go ahead and say results dot and then CSV, enter, and you can see that we copied 3 rows. If I open up my desktop, you can see that we have this file right here called results.csv, and if I press space, you can see that we have our CSV file, including the headers as well as the results from our query. So 3 rows, including Omar, Fernanda, and Adriana. And this is how you generate CSV files with Postgres. In this video, let's go ahead and learn about the big serial data type. So if you remember correctly, when we created both person and car tables, right here the ID is actually a big serial, so big serial. And if you remember correctly, I mentioned that big serial is a special data type which auto increments a number, right? And that number is an integer. So if I open up my terminal and if I describe both person and car, you can see that the type is actually big int. So there's no such type as big serial. But the special thing about it is that right here, so on this default column, you can see that it has this next val. And the next value is managed by this person ID sequence. The same for car. So you can see right here, so the type is big int, and the default value is this one right here, which is also managed by a sequence. So what I want you to do is to go ahead and select. So let's go ahead and select and then start from, and then we can actually select from both sequences. So let's go ahead and say person and then underscore ID and then sec for sequence, semicolon. If I clear the screen, now you can see that the last value is 3, and then the log count is pretty much how many times it's been invoked, and then right here you can see whether it's being called or not. So if I go ahead and select start from person, you can see that the last ID for this table right here is Adriana. So Adriana right here is 3. So this 3 represents this 3 right here. So it's the last value. So if I now go ahead and describe person, so let's go ahead and describe person, and you can see that we have this next val. So we can actually grab this because this is simply a function, and I can go ahead and say select and then paste that in and then end out with semicolon, enter, and you can see that the next val is 4. So if I clear the screen, run that again, you see that it's 5, again 6, 7, so on and so forth. Now if I go ahead and select and then start from and then person ID and then sequence, you can see that the last value is 8 right here, and you can see that it represents this one right here. So this means that if I go ahead and add a new person, so if I go ahead and select start from person, you can see that Adriana has ID 3, but because we invoked this function right here, so next val, right, and the next val now is 8, the next person that we insert into this table will have the ID of 9. So let's go ahead and try that. So I'm going to go back to my SQL, and then what we're going to do is grab this, and let's pretty much just change this to something else. So let's go ahead and say John, and then same surname, male, and then let's say just John, and then country, let's go ahead and say England. So I'm going to grab that, and then you can see that right here I'm not adding the actual ID, so this is managed by the sequence. Now I'm going to go back to item, and then if I paste that, you can see that the insert did work. But if I now select, so if I press up 2 times, select, and you can see that now John, so John right here, has an ID of 9. And this is how you pretty much use sequences. So sequences is simply a big int, so depending whether you use serial or big serial. So if you use serial, is an integer. If you use big serial, it's a big int. So if I describe person right here, you can see that the type is big int, which is managed by this sequence right here. And finally, another thing that we could do with sequences is actually restart the actual value. So if I pretty much clear the screen, and let me invoke this sequence right here, so this function right here. So I'm going to call it again, goes to 10, 11, 12, and then 13. If I go ahead and select start, and then from person ID sequence, and you can see that the last value is 13. So if I select now start from person, let's say that we want to restart with a value of 10. So basically the next person that goes into this table should have the value of 10. And to restart a sequence, we can say alter and then sequence, and then the name of the sequence, so person ID and then seq or sec for sequence, and then you can simply say restart and then with, and now the actual value. So let's go ahead and say 10. If I press semicolon, you can see the command worked. If I go ahead and select from sequence, you can see that now the last value is 10, right? Or actually, we could have restarted to 9, right? So if I go ahead and say 9, and 9 was the actual last value right here, so 9. So 9, enter. If I now select start from the sequence, the last value is 9. If I go ahead and invoke the function, so select next val, you can see that now it's 9, 10, 11, 12, 13, 14, 15, so on and so forth. And this is all you need to know how to work with sequences. Alright, in this video, let's go ahead and learn about Postgres extensions. So Postgres is designed to be easily extensible. And for this reason, extensions loaded into the database can function just like features which are built in. So basically, extensions are simply functions that can add extra functionality to your database. So to view the list of available extensions, go ahead and simply say select and then star from and then pg underscore available. So you can see that I've pressed tab, available extensions. If I press semicolon, and right here you can see the list of all extensions. So basically you can see, for example, the name, so the name column. So for example, this one, ref_int, functions for implementing referential integrity absolute. You also have, for example, XML2, so this is for XPath querying. You have PG visibility, so right here, examining the visibility map and page level. You also have a store. So this is simply a data type for storing set of key value pairs. Useful. So if I scroll down, you can see that there are a bunch of these guys right here. And you even have, so this one, which is really cool. So PLV8. So this allows you to write JavaScript functions. And this is really, really awesome. You also have, for example, SSL info, so information about SSL certificates, functions for auto incrementing fields, and a lot more. And this one here, so let's take a closer look on this one. So UID OSSP. So basically, this allows you to generate a universally unique identifier. So UIDs, a very interesting data type for primary keys and pretty much unique keys. So as you can see, it generates universally unique identifiers. So this makes it a good fit for primary keys. Alright, let's go ahead and learn how to use UIDs or universally unique identifiers with Postgres. So basically UIDs allows us to have a guarantee unique identifier whenever the identifier is generated. And also the cool thing about it is that it's globally unique, which means that collisions is pretty much impossible. And the way that they achieve this is by using some really cool calculations. Basically includes using a mixture of your MAC address, timestamp, and other key factors. But I'm going to leave a link where you can access this page and read more about UIDs. But basically it's very, very interesting. So also they have like different versions. So you can see, for example, version 1 is consisted of the date time and the MAC address. And then you have version 2, version 3, and version 4. So 3 and 5, and also version 4, which is completely random. So let's go ahead and learn how to use this with Postgres. So I'm going to go back to my terminal. And remember in the previous video, I've showed you how to select and then start from PG and then available extensions. And if we scroll down, you can see that we have this UID OSSP, right? And to use UIDs, we have to add the extension. So right here, you can see that we don't have any installed version. So let's go ahead and install that. So I'm going to press Q. And to install an extension, you simply have to type create and then extension. And then if not exists. So if not exists simply makes sure that it doesn't install the extension if already exists. So it's an idempotent command, which means that you can execute as many times as you want and it will only have an effect once. And the extension that we want has to be within quotes and simply type the extension name. So for us it's UID and then dash and then OSSP and then press semicolon, enter, and you can see that now we created the extension. So if I go ahead and select start from extensions or PG available extensions, enter, and you can see that now we have the version 1.1 installed. Now let's go ahead and learn how to generate a UID. So I'm going to press Q. And in order for us to generate a UID, we have to invoke a function. So if I pretty much just press backslash and then question mark and simply search for function and then scroll down. So right here, you can see that we have this command. So backslash df, and then we can see the functions. So let's go ahead and try that. So I'm going to press Q and then backslash df, enter. And now look at this. So now we have these functions right here, which are available to us. So remember, so because we just installed the UID extension, we have these functions right here. So prior to that, all of this was empty, which means that now we can pretty much just invoke these functions right here. So the function that I want is this one right here. So version 4. And if you remember correctly, version 4 is completely random. So I'm going to go back, and to generate UID, simply type select and then the function name. So UID underscore generate and then v and then 4, and then pretty much invoke the function. Press semicolon, enter, and now actually just let me make this bigger so you can see exactly what we're doing. Right, I think this is better. So now you can see that we randomly generated a UID, and this will be unique every time I invoke this, which is amazing. So let me just simply run the same command again. You can see this time is completely different, and I can run this a million times and basically the UID will never be the same. And this makes it a good fit for using UIDs as primary keys in our tables. And one of the benefits of using UIDs as keys is that it makes it very hard for attackers to try and mine our database. For example, if you had an API /users and then the actual user ID, so an attacker could actually exploit all the numbers, so 1 to, I don't know, 1 million, or any random number, and try to delete everyone or update information, so on and so forth. But with UIDs, it's very, very difficult for them to actually guess which person, for example, is in your database. Another benefit is that because they are global unique, that means that you can migrate data across databases without any conflicts. So for example, if you had a database A and database B, and basically if you were using big serials, so a big int or an int, then most likely you would have clashes when adding some data from database A into database B because of the actual IDs, right? If you were using big serials, it's auto incremented, and basically in both servers there's no way to actually tell that the IDs are different. And that's definitely a big advantage of using UIDs. Alright, in this video let's go ahead and change both person and car tables to use UIDs instead of big serial as their primary keys. So go ahead and open up person-car-2.sql from the exercise files folder, and what we're going to do is actually change the actual ID in both person as well as car. So just let me show you quickly the data types in case you have forgotten. So I'm inside of the Postgres data type docs, and you can see that this is a list that you've seen at the beginning of this course. So big int, big serial, so you've seen this one here, which is a auto incrementing 8-byte integer. So if I scroll down, you can see that we have UID right here, so universally unique identifier. So I'm going to go back to VS Code and let's actually change it. So instead of big serial, let's go ahead and change this to UID. So UID, just like that. And the same for the car table. So UID, just like that. And one more thing that we're going to do is actually improve upon the actual name of our primary key. So let's go ahead and pretty much just say that this will be a person underscore and then UID. And the same for car. So this will be car underscore and then UID. And then what we need to do is in the actual foreign key, so right here, so this no longer references a big int, so this has to be a UID, and this will be car and then UID, just like that, references and then car underscore UID. So car UID, so this is the foreign key that references car and then car underscore UID, which is the actual primary key. And now we have to change the actual inserts, right? So before we weren't including the actual ID because it was managed by the sequence. Now we have to be explicitly about it. So we have to include ID here, or actually no ID. So we renamed it to person and then underscore UID. So just like that. And then the actual value is UID and then generate underscore and then v4. So remember, this is the function that we saw in the previous video. So I'm going to pretty much just do the same for the rest. So I'm going to copy that. So this should be person and then underscore UID, and then paste that in. So invoking the function, the same here, again invoking the function, and let's do the same for car. So car and then UID values, and then we paste that function there. The same for this next car. So car underscore UID, and then paste the function there. All right, and finally what we need to do is actually change the order of these table creations. So remember, because we have a foreign key constraint here to car, so car must exist first. So just let me add car first here, and then the actual person. And one last thing that I forgot is that this should be car and then underscore UID, just like that. So I'm gonna save this as person and then dash car and then dash and then 3.sql in my desktop. So I'm gonna save that, and we are good to go. Now open up iTerm or terminal or command line if you're on Windows. Now, because we're going to recreate these two tables, let's go ahead and drop the table called person first, because there is a foreign key constraint between person and car. So go ahead and drop person first, and also drop car. So we're going to drop car. Now I'm going to go ahead and execute this file right here. So this file from my shell. So I'm going to do \i for execute from a file, and then the destination of that will be /users /amigos code /desktop / and then person -car -3.sql. Now if I go ahead and execute, you can see that everything works. So we have two creations, so two table creations, and then few inserts. Now if I clear the screen and do a select start from person, so this time let me actually go ahead and press \x, so you can see that the expanded display is on. Perform the same select, and you can see that the person UID is now the primary key, and the actual value is a randomly generated UID. So right here you can see that they are absolutely different. So in fact, let me go ahead and describe person. So person, so you can see that the actual type is UID. Let's also go ahead and do the same for car. So select start from and then car, and you can see that we have two cars right here. So one last thing that we have to do is actually assign some cars. So let's go ahead and do that. So let's go ahead and update, or first let me make this smaller, the expanded display, and simply type \x, and that toggles it off. So I'm going to make this a bit smaller so you can see exactly what we're doing. Now let me go ahead and select start from person, and also select start from, or actually all uppercase, from and then car. There we go. So now let's go ahead and update, and then person set and then car underscore UID equals 2, and let's grab this first UID, so this one here, and this has to be within quotes, where, and then person underscore UID. So we're going to assign this car to, let's say this time Adriana gets to get the car. So we're going to paste that in, update that, and also let's go ahead and assign a car to Fernanda. So Fernanda will have a car, so just let me delete that, and the car will be GMC, and then grab this car UID and then paste that in, enter. You can see that works. Now let's go ahead and perform a join. So select start from and then person, and on a new line join, and then we're going to join car, and then we can say on person dot and then car and then underscore UID equals to car dot car and then UID. If I press semicolon, enter, and you can see that if I make this smaller, so because we have lots of columns, so press enter, still not enough, but let me go ahead and add the expanded toggle, so \x, and then perform the same query. And now you can see that this first record, so this one right here, so this is Adriana, and you can see that it has the person details as well as car details. So it's a join between those two tables, and the same for Fernanda. And you've learned this on the join section. So I can make this bigger now so you can see it properly. So now I want to show you one thing, and that is, you see that we perform a join right here, right? So join car on person.car UID and then car and then .car UID. So because these fields are the same, so the keys, i.e. the foreign key and the primary key are the same, we can pretty much just remove that, and then I can say join car and then using, so this is using, and then car UID. Because both the primary key and the foreign key have the same name, instead of you saying car and then .car underscore UID, person.car UID, you can simply much ditch that and use this using keyword, which is much nicer. So let me go ahead and press enter. You see that also works. So we could also do a left join. So we want to grab everyone with and without a foreign key constraint. So for that, left and then join, and then press enter. And now you can see that we have 3 people back, and Omar, he doesn't have a car. So right here you can see that car information is empty for him. And let me go ahead and perform a left join, and then where, so let me go ahead and say where, and then car dot and then star is no. So now we should only get Omar. There we go. And this is how you use UIDs with Postgres. And also you saw that this keyword right here, using, is really useful when both the foreign key and the actual primary key have the same name. Alright, first I want to congratulate you for completing this course. Now you should be aware of how to use Postgres. You know, we've gone through a lot of important concepts that you must know in order for you to be able to open a shell or PSQL and start writing queries that really make sense. So everything that you've learned in this course is very valuable. And if you have any questions, go ahead and drop me a message, as I always say, because I really want you to engage. And if you feel that there was, for example, a specific topic or concept that you have not understood correctly, go ahead and let me know, and I'll make my efforts to explain it further. So the next step for you now is to either take one of my courses on Spring Boot or Node.js and Express. So Spring Boot allows you to create very fast applications using Java, or if you are into JavaScript, you can take the Node.js and Express course, and basically you can take whatever you've learned from this course and apply it to create backend applications, right? So SQL, or the actual database, is the foundation of your backend, right? So this is where you take some data from clients and then you store that in a database. So you've learned the database part. Now you should learn the actual backend application, right? So how you process information, how you create RESTful APIs, right? How you can provide clients with services that they can use and make sure that your system has the right behaviors. And this is when Spring Boot and Node.js allows us to do. So they allows us to create applications that we can deploy and have clients use it. So you've learned the database part. Now it's a way of you taking an application and connect to a database and start storing, retrieving, and manipulate data. And finally, if you want to further enhance your skills with Postgres, go ahead and check my course on advanced Postgres. So this is where we go into much more advanced topics such as indexes, functions, more complex queries, common table expressions, triggers, views, and all other important concepts that you must know. Right? So in this course, we cover the essentials, and this allows you to get going. So now you can expand your knowledge by taking the advanced PostgreSQL course. So this is all for now, and I want to thank you so much for being my student, and I'll see you on the next course. Join me there. See ya.